we are live now. I think we are live now. Good afternoon, everyone. Good afternoon, all those who have joined. Hi, everyone. Hi, good afternoon, Supraja. Good afternoon, Nitin. Good afternoon, everyone who has joined. Good afternoon, Kishore. Good afternoon, Sai Kiran, Sonima. Good to see all of you guys. Good afternoon, Ayushi. Okay, I see a lot of guys have already joined, and I know that a few more of you will be joining. So good afternoon to everyone, and in today's session I hope to cover all of geometry and get you guys to practice some good quality questions so that you are fully prepared for the CAT exam. So one last reminder, so the CAT application deadline has been extended. So for those who have not filled the CAT form, please fill it immediately. For those who have filled it already, that's fine. But those who have forgotten to fill it, please fill the CAT form immediately. Good afternoon, Tarun, Paridhi, Naman, Saurav, Srinivas, Jairam. Good afternoon, Mukund. Good afternoon, Sayam, Mithun, Datta. Good afternoon, everyone. Good afternoon and good to see you. A good number of students today, and I hope this is like a very good stream where we learn everything, we cover everything, and that we solve good quality questions. And I hope that all of you guys solve with me. Everyone attempts the questions, and either way, whether you get it right or wrong, we learn how to solve. Okay. Good afternoon, everyone. Okay. Kindly conduct a LRDI marathon next. Supraja definitely will try to do that. So we are going and finishing almost most of Quant is done. Geometry will be done by this next session. And after that, I will try to do an LRDI session before going to modern maths and number systems. So good afternoon. I don't know much about geometry. I hope this session becomes a great time for me. Jay, don't worry. This session we will cover everything. Ma'am, please make a live mock for DILR, ma'am. The VRC live mocks is so helpful. Sure, we'll try to do that, Datta. We'll try to do an LRDI live mock. Okay, sure. Finally, geometry is here. Good afternoon. Good to see all of you guys. Okay, let's go. Okay, RC marathon. Okay. RC marathon is slightly difficult to do because it requires reading multiple passages out loud, but we'll try to do that. Okay, one small request before we begin. Guys, all those who have joined us, if you think this stream is helpful to you, if this helps you prepare for CAT, please like this stream. If you like the stream, we reach more students. If we reach more students, it motivates us to do more of these sessions. Okay guys, so please like the stream. Ma'am, was waiting for geometry for a long time. Okay, I know this is like a very awaited topic, so let's get started. This is going to be a longish session because, so in this session we are doing triangles and circles. In the next session we will do coordinate geometry, polygons and solids. Okay. First, final reminder for those who have not put in their or not filled the application form, please fill it. The deadline has been extended by 3 days. You don't have much time. So guys, please fill the form. You need to fill the form as soon as possible. And one more thing, it is like the deadline is September 20th. So you don't have many days. And the guys who are looking for a crash course so that you make the best use of the last few days that are there, do check out Cracku's 75-day crash course. So it starts 15th September, but you haven't missed this. So again, do check out, like you won't miss it, is starting on Monday. And basically in the next few days, we will be like next 75 days, we'll be covering the entire syllabus, and we'll also give you adequate amount of practice to crack the CAT exam. So if you have any questions about it, if you want to know more about the CAT course, do call us on this number. It is 630-323-9042. We'll be happy to answer any questions you might have about the crash course. So the crash course is specifically for those guys who are pressed for time, who want to finish the entire syllabus in 75 days. Okay, so let's get started. Okay, we'll start with triangles. Triangles, I will be covering the basic triangle properties. We'll split it up into some parts. So I'll cover the triangle properties, what are the different parts of a triangle, and each time we'll have a few questions to check our understanding. So let's start with what are the basic triangle properties. I guess most of you know what is the sum of interior angles of a triangle. What is the sum of interior angles of a triangle? Given any triangle, say ABC, this is the most basic, the sum of angle A plus sum of angle B plus sum of angle C is 180 degrees. This is like one of the basic fundamental properties of triangles. In addition to that, you can say that suppose this is x, angle x and angle y, then this exterior angle over here, this will be x plus y. This is true for all exterior angles. Like if suppose this is x, this is y, this is z, this angle over here will be y plus z. Similarly, this angle over here will be x plus z. So the exterior angle is basically the sum of the other two angles of the triangle. So the exterior angle of angle C will be the sum of angle A and angle B. Similarly, the exterior angle of angle A will be the sum of B and C, and so on. This is like the basic property of interior angles. This is something that you should know. Another thing that you should know is that there, whenever it is given that okay, a triangle is an isosceles triangle. An isosceles triangle by definition is a triangle where two of the angles are equal. Okay, so if this is say ABC, and we are given that the triangle is isosceles such that AB is equal to AC, then both of these angles become how much? Both of these angles become x degrees each, because if the sides are equal, the angles also have to be equal. It becomes an isosceles triangle, and then this remaining angle becomes how much? This becomes 180 minus 2x. This is basic. We will cover what is isosceles, equilateral and right angle again. But basically, whenever there is an isosceles triangle, the two angles are equal. The third angle becomes 180 minus that particular angle. So these are the basics of angles. But what are the basics of triangles? See, the basic property of a triangle is that the interior angles must add up to 180. So however you draw the triangles, all angles, interior angles will add up to 180. Similarly, there is a limiting property for the sides also. What is the limiting property for the sides of the triangle? Suppose this is a triangle ABC. Suppose this is length, say, this is length A, this is length B, this is length C. These are the three lengths of the triangle. Okay. Then the perimeter of the triangle is defined as A plus B plus C, basically the sum of all lengths of the sides. The semi-perimeter S is defined as P by 2. So this is A plus B plus C by 2. Okay. For some this might be basic, but I just want you guys to be patient because I want to cover everything. I want to make sure that everybody is like following along, and I want to cover a lot of formulae, and with geometry there are lots of formulae, so please be patient while we cover the basics of geometry, because I don't want anything to be left or anything to be not known. Okay, so this is the semi-perimeter. Okay, now the basic relationship to decide whether a triangle is possible or not is that the sum of two sides, any two sides of the triangle should be greater than the third side. So A plus B should be greater than C. B plus C should be greater than A. A plus C should be greater than B. Or you can say it in this way that if I add C to this, this becomes 2C. Or I add A to this, this becomes 2A. And I add B to this, this becomes 2B essentially. Or if I divide it by 2, I will say that C is less than A plus B plus C by 2. Or A, B, C, all three of them are less than the perimeter divided by 2. Perimeter divided by 2 is basically semi-perimeter. So each side of the triangle has to be less than the semi-perimeter, not equal, strictly less than the semi-perimeter. What happens if it is equal to the semi-perimeter? Suppose that say A is equal to B plus C. If this is the case, what will happen if A is equal to B plus C? Look at this triangle. What happens when A is equal to B plus C is, if I split A into two parts, B and C, what will actually happen is that the vertex A will actually lie on BC. So there will be no triangle, there will be three collinear points. So whenever you have a triangle such that it has height, the vertex is not on the base itself, you need that B plus C has to be greater than A, strictly greater than A, not equal. Okay, so you have to remember each side of the triangle has to be strictly less than the semi-perimeter. The sum of any two sides of the triangle have to be greater than the third side. Okay, this is the basic property of triangle. Whenever you are asked, okay, how many triangles are possible, or is this triangle possible, when you have to figure out is a triangle possible, you have to just check that this rule is followed or not. This is the basic rule that has to be followed to check whether a triangle is possible or not possible. Now let's get to the types of triangles. So I had already mentioned isosceles, but let's consider what are the different types of triangles. Suppose you have a triangle such that ABC, such that all sides are equal. If all sides are equal to A, it's called an equilateral triangle. An equilateral triangle is also equiangular. It is equal in length and equal in angle. If all three angles are equal and their sum is 180, what would be each angle? 180 by 3. So each angle will be 60 degrees. Okay. So this is basically a simple equilateral triangle. Another type is when two sides are equal. This is called as an isosceles triangle. Okay. When two sides are equal, it is called an isosceles triangle. In isosceles triangle, the angles of the base with those two sides, those two angles will be equal. So this angle between A and B and this angle between this A and B, these two angles will be equal, and as I mentioned, this will be 180 minus 2x. Can we call an equilateral triangle an isosceles triangle? Yes, an equilateral triangle is a special type of isosceles triangle where A is equal to B. So all equilateral triangles are in fact isosceles triangles also. The idea is that isosceles triangles are where two angles are equal, but if say all three angles are equal, it becomes equilateral. So consider that if you have something like this, okay, you have A, B, C, and suppose this is say 70, 70, what would be the last angle? 180 minus 2 times 70, so this will be 40 degrees. This is an equilateral triangle where two angles are equal and the third angle is not equal. Okay. The third type of triangle is where there is no shape, no such rule on like angles or side. That is called as a scalene triangle. So here A, B, C. So if say A is not equal to B is not equal to C, then we have something which is called as a scalene triangle. If the sides are not equal, the angles are also not equal. So here neither the angles are equal nor the sides are equal. Okay. So this is a scalene triangle. Another way to actually classify triangles is to say acute right angle and obtuse angle triangle. So what is an acute angle triangle? An acute angle triangle is basically a triangle in which the largest angle, suppose your largest angle is say x, the largest angle is say less than 90 degrees. So suppose A is the largest angle. If this angle x, if x is less than 90 degrees, you call it an acute angle triangle. Similarly, you have something which is called as a right angle triangle. Suppose the largest angle A, is equal to 90 degrees. This x is equal to 90 degrees. Then this is called as a right angle triangle. Now if this is 90 degrees, you don't show it with a circular curve as such. Whenever an angle is 90 degrees, we show it with a square kind of a depiction. So whenever a square like this is given, it indicates that it's a right angle, that is it is a 90 degrees angle. So why right angle? Whenever something is upright, okay, then it is perpendicular to the floor, it is 90 degrees to the floor, so it's called as the right angle. So right angle is basically when the largest angle is equal to 90 degrees. Then you have something like this, where the largest angle x is greater than 90 degrees. This is called as an obtuse angle triangle. Okay. Now there is a relationship that you need to know between the sides and the type of triangle that is there. Suppose this is say A, B, C. Okay, sorry, this is C. This is A, A, B, C. And say this is A, B and C. Here the largest angle, whatever is the angle, the largest angle is A. Always remember the largest side is opposite to the largest angle. So if A is the largest angle, the side A is the largest side. Now remember, whenever it is an acute angle triangle, A square will be less than B square plus C square. Why? Because the angle, this is basically when you consider the split as such, that A square will be less than B square plus C square because the angle X is less than 90 degrees. When it is exactly 90 degrees, by Pythagoras theorem, a square will be equal to b square plus c square. So this is called as Pythagorean theorem. Here a is called the hypotenuse, it's the longest side. So hypotenuse square will be the sum of the squares of the other two sides. So here a square will be equal to b square plus c square. In an obtuse angle triangle, a square will be greater than b square plus c square. So these three relationships also you should remember. So if you are asked how many triangles are possible, one of the things that you should look for is that a, b, c should be less than s. And then if you are asked how many of these are isosceles, you can figure that out by assuming that okay, two sides are integral values, how many integral values such that they'll be equal. Now if instead of that, if they are asking you how many will be acute, how many will be obtuse, then you have to use this particular relation. If you have to figure out how many acute angle triangles are possible, you have to use these relations. Okay, how many acute, how many obtuse, how many right angle. Okay, so this is the basic idea. This is the relationship between the angles and the sides. This is also the three types of classification that you can have. You can have equilateral, isosceles and scalene, and by angles you can have acute, obtuse and right angle triangle. Okay, let's go. Okay, this is an easy question. Actually, this question is not a difficult question as such. It is based on the simple concepts that we have done till now. The concepts we have done till now are not difficult, right? So, but you will find this challenging. The concept is simple, but you have to basically use it again and again and again till you find the answer. So I want all of you guys to solve this one. How long will this class be, Rishabh? This will be a slightly big class because we have a lot of slides, lot of formulas to go through. So this will be a slightly bigger class. Dilip, I expect this to be around 3.5 to 4 hours. Guys, come on, try to answer this question. And I see a lot more students now. So guys who have just joined, please like the stream. It helps us reach more students. It motivates us to do more of these streams. So please like the stream. Ma'am, for LRDI, how to improve? Nancy, what I would say is that for LRDI, I want you to focus on puzzles, arrangements, charts and tables. I want you to first learn the representation format for each one of them. How do you solve linear arrangement? How do you solve circular arrangement? How do you solve arrangement across levels? For puzzles, how do you depict the information? All of those things first, and how do you read different types of charts? Do those basics. After that, I want you to solve 50 questions or 50 sets of each type. If you do well in these 4, at least 2 sets out of the 4 or 5 that will come in CAT, you will be able to solve. Is there any part of this diagram somebody is not able to see? If you are not able to see the diagram, just let me know. When will be number system session? We'll hold it, Anuja, don't worry. Basically, geometry will take one more session. After that, we'll try to do LRDI and then we'll do number systems, then maybe modern maths. Where is E? Sorry, E is this one. I'll use another color. This is E, sorry. Guys, try to fill in the values as much as possible. As much as possible, try to figure out what the value will be. We have to find out what this angle is. So let's say this is X. Now use the idea that I have mentioned about like what is the sum of the interior angles, what is the exterior angle. So use that iteratively, that isosceles triangles have equal angles. Use that multiple number of times because there are multiple isosceles triangles and there are multiple exterior angles. Just you need exterior angles and isosceles triangles, these two basic concepts, and you can solve this one. Come on guys, the time is up, but I haven't gotten a single answer yet, so please try to solve this one. This is not very difficult, a very basic concept, you can do it. Just try to iteratively use the same concept again and again till you get the answer. I have one answer, I won't tell whether it is correct or not, but I want more of you guys to attempt. I'm giving you 1-2 more minutes. Come on guys. somebody has given the answer, but I'll give you the options also because both was not fitting. These are the options. Sorry Alex and Vikas, it's not one of the options. Yeah, how to improve in VRC? Pranjal, I would say that if you're very weak in VRC, first focus on RC. Read 2 articles every single day. Do 2 RCs every single day. I want you to practice active reading. That is, you read every paragraph, write down the main point. Keep a separate register for RCs and articles where every article you read, where every RC you read, you write down the main point of each paragraph that you have read. That will help you basically in staying focused, staying engaged with the RC. That will also improve your accuracy rate in RC. It will negatively affect your attempt rate in the short run, but over time you will be able to recover from the this as such. So guys, try to answer this. I see some more people have answered. Pranjal, I want you to practice a lot of RCs, okay? Okay, so some of you have been able to answer 25, 25, 20 and 25. So some of you have said 25, some of you have said 20. The guys who have, okay, good answers, number of answers till now, okay? So the guys who got stuck, Sarthak, I'll answer your question. I've seen your question. I'll answer this after the question is done. But for the guys who got stuck, how and where do you think you got stuck? So let's try to see, once this X is there, what can I say about the different angles? The AG, AB, GF, FE, CD, DE, BC, all of these are like whatever is there in yellow is equal, and only this information is given. Nothing else is given other than these are equal angles, equal lines. Now if there are equal lines, these are isosceles triangles. So AGF will be an isosceles triangle where AG is equal to GF, which means that this angle A will be equal to this angle A, GFA as such. So these two angles, angle A and angle F will be equal, so this will be X, okay. Also this angle, consider CAB, okay. If I see CAB, this angle A will be equal to angle C, so this is also X. So I've gotten two angles which is equal to X. What can I say about this angle over here? This angle B. Here is X, here is X. Are you guys able to see properly this blue, or should I choose another color which is more visible? Maybe I choose red. Okay, so this angle is X, this angle is X. So what would be this angle B? It's the exterior angle of CAB. So this will be 2X. Okay, if this is 2X, consider CBD. If this is 2X, this angle will be equal to that angle. So this is also 2X. So I am finding multiple angles which are equal to each other because they are isosceles triangles. So I have to consider every isosceles triangle that is there, every exterior angle that is there. Now if this is X and this is X, this is 2X. Similarly, if this is X, this is X. How much is this? This is also 2X. So this is 2X, this is 2X. Now consider this EFG. If this is 2X, EF is equal to FG. So this is also 2X. So I've gotten another angle which is equal. Let's see which other things should I use. What other values can I use? This is 2X, this is 2X. The exterior angle, this would be 180 minus 4X, right? Because this is 2X, this is 2X, this is 180 minus 4X. This is X over here. So this remaining value would be 180 minus X minus 180 plus 4X. So this has to be 3X. Now if this is 3X, this is 3X, DCE is 3X, but DCE and DC and ED are equal. So even this has to be 3X. So this is also 3X as such. So this is X. If this is X, what can you say about this angle over here? See, again, even by symmetry, I can say that if this angle is 3X, this angle should also be 3X. But even then, we can say that, okay, this is X. If this is X, this remaining should be what value? This should be 180 minus 4X. This is again 3X. This again should be 3X. So we get that this is 3X, this is 3X. Angle E is 3X. Angle E as in AED is 3X. Angle ADE is also 3X. And what is our original angle? DAE? That is equal to X. These are the three angles of a triangle. If I add them up, how much do I get? I get 7x. But 7x should be equal to how much? It should be equal to 180. So my angle x is equal to 180 by 7. That roughly comes to about 25 point something something. So the closest value is 25 degrees, which is option D. This is not difficult. The only thing that you have to see is that you have to continuously use the same principle again and again of exterior angles, of equal angles in isosceles triangles. So that just those two principles, if you had used again and again and again, you would have ended up with the answer. Okay? Correct? Okay. 25 degrees, most of you got it? Okay. Okay. Ma'am, my current marks is 48 marks, which is what is a realistic percentile in if I put a lot of effort to improve in quant in the next 2-3 months and daily practice. If 48 marks is total marks, I would say that focused on the weakest section. Tell me the split also. If 48 marks are there in quant, then you are doing very well. Then you have a very good chance of 99.5 plus. But if 48 marks are total across 3 sections, first tell me what is the split across the sections. Okay. Okay, how 180 minus 4x? How 180 minus 4x? This is 2x over here, this angle. Consider this triangle over here, okay? BCBD, okay? This angle is 2x. This angle is 2x. So this becomes 180 minus 4x. If this is 180 minus 4x, this is x, this becomes 3x, okay? Okay, everybody is fine with this answer? Anybody stuck still over here? Okay, got it, okay. Sarthak, to answer your question, how to improve in algebra and unable to solve even complete basics of mod, function and inequalities. I think, see Sarthak, the idea of mod, function and inequalities is secondary. First you have to get good at linear equations, quadratic equations, solving quadratic equations, factorizing equations. Once that basic set is there, then you can go to inequalities, mod and functions. Because they are basically, mod uses most of the time quadratic equations ideas. Also get used to factorizing, like say cubic equations. Make sure that basics are done. Once that is done, I would say for mod and functions and for inequalities particularly, try seeing the graphing method, because if you start with the graphing method, it becomes easier for you to visualize how things are moving. When it comes to inequalities, try to draw the number line. So when you have ranges, you have to draw the number line and say that, okay, these are the factors. So the areas of interest or points of interest would be like say these 4 points in which the value of the inequality is likely to change. When it comes to say mod function, you have to again split it up into different parts. So you have to then again draw the number line, consider the different points at which the value of the mod will change, and independently consider each parts of the equation for different ranges as such. See, the idea of splitting the mod function range wise, splitting the inequality range wise, all of that takes a lot of effort. But it is possible only if your ideas or basics in linear and quadratic are very clear. Your ability to factorize is very good. If your ability to factorize equations is not good, right, then you will find it very difficult in these particular areas. So first focus on that, get that done. Okay, so let's get started with the triangle parts. So here, this is basically where till now whatever part we have done is much more easier than the things that we start, because triangle parts we have to basically learn the names of different things, the formulas of different things, a lot of things to remember. Okay, so let's get started. So first one is perpendicular bisectors and circumcenter. Okay, so suppose this is your triangle ABC. In general, what is a perpendicular bisector? Suppose you have just BC. Okay, for any segment, the perpendicular bisector is basically the right angle line that goes through the midpoint of BC. So if you say that D is the midpoint of BC, if I draw a line which is perpendicular through D, it's called as a perpendicular bisector. That is perpendicular, meaning it is at right angle and it bisects the line. Now if I draw the perpendicular bisector, suppose this is the perpendicular bisector of BC going through D, perpendicular bisector of AC going through E, perpendicular bisector of AB going through F. So this point at which all the perpendicular bisectors intersect is called as the circumcenter. Circumcenter is basically called circumcenter because it is the center of the circumcircle. If I take this point and I measure this length, okay, this length which I denote by capital R, I put my compass over here and I draw a circle, I will get the circumcircle of this triangle. Okay, that's why it's called as the circumcenter. So what do you get when you have perpendicular bisectors of sides? You get the circumcenter. The circumcenter, if you take the distance from the circumcenter to the vertex, that is the circumradius, you draw a circle that goes through every single vertex of the triangle. So it is basically a circle that circumscribes a triangle. Circumscribes means it covers from the outside. That's called circumscribing. So when you circumscribe any figure, so suppose it is a square, anything like that, it is a circle such that all the vertices of the figure lie on the circle. So whenever all the vertices of a figure lie on the circle, it is circumscribing the figure. What is inscribing? So if I take the same figure, but I draw a circle such that it touches all the side from inside, it is called as inscribing. So same with triangle. If I draw a circle such that it touches all three sides, it is called as inscribing. So when I say inscribe, it means I put the circle inside. If I say circumscribe, I put the circle outside. If I inscribe, I touch the sides. If I circumscribe, I touch the vertices. Okay, this is the basic idea. So in this case, when you take perpendicular bisectors, you are circumscribing. You draw a circle which goes through all the vertices. I'm just telling you what all of these is. Then I'll tell you how to actually use that, what is the purpose of that, what is the idea behind that, etc. Consider angle bisectors. What is angle bisector? If this is an angle, okay, angle B, the angle bisector basically bisects the angle into two equal parts. So if this angle was say 60 degrees, it will cut into two parts of 30 degrees each. That is an angle bisector. Now if I do the angle bisector of a triangle, what do I get? If I do the angle bisector of a triangle, say this is A, B, C, okay, angle bisector here, angle bisector here, angle bisector here, they will all meet at a point which is called as the incenter of the triangle. If I take this particular point, drop a perpendicular to the one of the sides, take this length, whatever is the length, as the radius and draw a circle, that circle would be inscribed inside the triangle. So therefore, when I use angle bisectors, the point of intersection is the incenter. The distance of the incenter from the side, perpendicular distance of the incenter from the side is called as the inradius. And if I use the incenter and inradius, I get the incircle of the triangle. There will be questions on this later, but right now I just want you to know the word terminology where everything comes from. Okay. Similarly, we have medians and centroid. Now medians and centroid. So remember, what is a median? So right now we were bisecting angles, bisecting sides. But for bisecting a side, we use perpendicular bisector. But instead of using a perpendicular bisector, suppose I find the midpoint of the side and just join the opposite vertex to that midpoint. This is called as a median. The line joining a vertex to the midpoint of the other side is called a median of the triangle. Similarly, I can draw another median like this, another median like this. So here say this is BE and CF. These are the three medians of the triangle. The point at which they intersect is G. This is the centroid of the triangle. What is the point of the centroid? Why is centroid a important point as such? See, generally whenever you have a centroid, it is basically the center of mass. If you had a triangle which was made of wood, okay, and you basically like hung it from one of the vertex and you drew a straight line about how it hung, okay, the line that goes through will be the median. Similarly, you hang it from other vertex, etc., etc. The center of all those points of intersection would be the centroid. Now, centroid has a lot of importance in like say physics, etc. So it's a big important concept in geometry in itself. But you have to just remember, centroid is the point of intersection of the medians. Medians is basically the line joining the vertex with the midpoint of the other side. Now, what is the important thing to remember about the centroid? The centroid divides the median into the ratio 2:1. So AG to GD, this ratio is 2:1, and it is true for all medians. So even BG to GE, even this will be 2:1 and so on. Now you have to think of the relationship between what is can somebody quickly tell me what would be the relationship between the area of ABC and the area of BGC. Quickly, can you tell me what would be the ratio of ABC to BGC? If the centroid divides the triangle in the ratio 2:1, what would be the ratio of areas ABC to BGC? 1:6, 1:3. Okay, it is the larger triangle ABC, this area by the triangle of BGC, this ratio is 3:1. Why is it 3:1? See, consider ABC. ABC, if I drop the altitude, okay, whatever is the altitude, okay, this altitude is some particular, whatever is the altitude, say this is AD dash, okay. Now what is area of triangle ABC? That would be basically half into BC into AD dash, okay. Similarly of BGC would be somewhat half into BC into, say, parallel from G, if I drop another one, G double dash or something like that. Over here, when the centroid divides the triangle centroid divides the median in the ratio 2:1, by basic proportionality theorem, I'll come to it later, but basic proportionality theorem would also mean that if I draw lines parallel to this G going through AD dash, it will be cutting the line altitude also in the ratio 2:1 by basic proportionality theorem. I'll tell you the basic proportionality theorem later, but the idea is that the centroid cuts all lines in the ratio 2:1. So that would mean that this height of our smaller triangle BGC is also 1/3 of this larger altitude of the area. So this will be 1/3 of AD dash. So what do we get? This divided by this into 1/3. So this is 3:1. In general, remember that if this is your triangle and this is the centroid G, this is ABC. So GBC will be 1/3. Similarly, AGC will be 1/3 and ABG will also be 1/3. Because the G, it divides all altitudes in 1/3. It divides, the base remains the same, the altitude becomes 1/3. So each part of this, if I connect the centroid with each of the vertices, I get 1/3, 1/3, 1/3 triangles. So basically the centroid is the point at which the part or like the triangle is divided into 3 equal parts. So if I connect each vertex to G, I get 3 equal parts of the given triangle. Okay, so the guys who said 3:1 are correct. The centroid, remember the centroid divides the triangle into 3 equal halves. Let's go to altitudes and orthocenter. Okay, consider altitudes and orthocenter. What is an altitude? I just use the term also altitude. So what is altitude and orthocenter? Altitude is nothing other than a perpendicular, but the perpendicular need not bisect the other side. It's just a perpendicular dropped from the vertex. So that is also known as the height of the triangle. So if I drop a perpendicular from the vertex, this point D, this need not be the midpoint of the triangle. This is just a perpendicular which passes through the other vertex A. This is called the altitude of the triangle, and it is also sometimes called as the height of the triangle. When you are calculating the area of the triangle, we often use half into base into height, right? So the altitude is the same as the height. So the altitude has a lot of importance whenever you are calculating area. That's what you need to calculate area. You need the base length, you need the height length. Once you have that, you can calculate the area very easily. So the altitude is basically the line perpendicular drawn from the vertex to the other side. Similarly, if I draw the perpendicular from this and the perpendicular from this, so this is a BE and CF, the points at which they intersect is called as the orthocenter. The orthocenter has no significance, it is never asked. The altitude is of significance because it is asked, but the orthocenter is almost never asked. There is very little significance to it. But always remember, the perpendicular bisectors, circumcenter. Just perpendiculars going through the vertex, orthocenter. Perpendicular bisectors, circumcenter, circumradius, you can circumscribe the triangle. just a perpendicular bisector, it's the altitude or height of the triangle, can help you calculate area. Okay, so these basics of the triangles done. I will come to the part which is of actual interest, which actually is often asked. See, whenever they ask these circumcenters, centroids, all of these things, it is rarely for a random triangle. They will generally ask these for equilateral triangles and right triangles because there are shortcuts there. There are shortcuts that you need to remember for the values for centroid, for all of these things, for equilateral triangle as well as for right angle triangle. So let us look at what are the short formulas for each of these type of triangles. So for an equilateral triangle, remember all that we discussed till now. The perpendicular bisector, altitude, circumcenter, incenter, so circumcenter, orthocenter, centroid and incenter, all four things in a equilateral triangle are the same. So if I draw a median, okay, in an equilateral triangle, not only in an equilateral triangle, even in an isosceles triangle, if I draw a median in an isosceles triangle such that these two angles are say equal, right, then this median will be a perpendicular bisector. It will be an altitude of the triangle. Why? Basically it will be because of symmetry. So whenever we are drawing a, whenever it is a isosceles triangle, the median bisects the triangle. It is a perpendicular bisector of the other side. But in general, because isosceles triangle does not have direct formulas, equilateral has direct formulas that we need to remember. Let's focus on the equilateral triangle. In equilateral triangle, remember, centroid, incenter, circumcenter, orthocenter, everything is one. This, let's call it G. It is, centroid is the same as incenter, is the same as orthocenter, is the same, everything is same. Now you have to basically remember in this that what is the altitude? The altitude is basically the height of the triangle. Here each side, let's say that each side of the equilateral triangle is A. So what would be the height of this particular triangle? This is 60 degrees, okay? This, because this is now the median also. This is like the, it divides the other side in half and it is a perpendicular bisector also. So this is 90 degrees, this is 60 degrees, this becomes 30 degrees. So our altitude AD is how much? AD, if I say, is sine 60 is AD by the hypotenuse, which is AC. AC is basically small letter a, so this is A. So AD is sine 60, A sine 60. Sine 60 is how much? Root 3 by 2. So the altitude of a equilateral triangle of side A is root 3 by 2 times A. Remember, this is something that you should directly remember. You should not have to think over there. If it's an equilateral triangle, sides are A, the height of the equilateral triangle will be root 3A by 2. What would be the in radius? What would be the circumradius? I want you to remember this, mug it up. There are ways to calculate this, but I want you to remember this or mug it up in some way. I will tell you how to get this. The way to get this is through the area formulas. We haven't done area formulas, but there also I can show you how that comes. But I want you to remember, if the side of the equilateral triangle is A, the in radius will be A by root 2 root 3. Okay? A by 2 root 3. Is it visible or you guys are not able to see this? Root 3 by 2. Yeah. Are you guys not able to see this clearly? So altitude is root 3 by 2 times A. Okay? In radius is A, I'll just write it over here, A by 2 root 3, okay? This is the in radius. It is shown by the small letter r. We derive this through the area formulas, which I'll discuss later on. I'll come to that. Then I'll show you how exactly you are getting it. But I want you to mug it up. The in radius of an equilateral triangle is A divided by 2 root 3. The circumradius of an equilateral triangle is A divided by root 3. So you can see that the circumradius is essentially 2 times the in radius. The circumradius is equal to 2 times the in radius. If I have given you that, okay, the side of the equilateral triangle is 6, what is the circumradius? Can you tell me? If the side of the equilateral triangle is 6, what is the circumradius in that case? If the side of the equilateral triangle is 6, What would be the circumradius? What would be the in radius? Yep. So it would be 2 root 3 Sonimba, correct, and the in radius would be just root 3. Okay. This I want you to remember. It has immediate application in a lot of questions. Whenever in radius, circumradius is given, equilateral triangle is there, you can directly apply. Okay. Then you have the idea of, so altitude remember, in radius remember, circumradius remember. Then the other type of triangle where questions come for in radius, circumradius and even median is of right angle triangle. So for right angle triangle, let me tell you what is the relationship. So suppose this is ABC, suppose it is right angled at B, okay, so and the lengths are say A, B and C like this. It is not opposite side, so just remember C is the hypotenuse, A and B are the height and the base as such. Over here what would be the orthocenter? See, the orthocenter is the point of intersection of the perpendiculars of vertex. The vertex perpendicular from A is here only at B. The vertex perpendicular from C is at B only. The vertex perpendicular from C, the other vertex here will pass through this only. So the point, orthocenter point, which is the point of intersection of all perpendiculars from vertices, will be the point at which the right angle is there. So vertex B itself will be the orthocenter. What would be the circumcenter in this case? What would be the circumcenter of a right angle triangle? What would be the circumcenter? If somebody knows, just let me know. Tell me, what is the circumcenter of this particular right angle triangle? C by 2. Midpoint of the hypotenuse. Exactly correct, Uma. That the midpoint of the hypotenuse is the circumcenter. Why? Because if I take this midpoint of the hypotenuse, I take this distance, I will get A also, I will get C also, I will get B also. This will be a circle. So because of that, the circumcenter of a right angle triangle is the midpoint of the hypotenuse. What would be the incenter? The incenter will be some point, the incenter will be some point which is inside the triangle. There is no direct formula or direct way of finding the incenter, but there is a formula for the in radius. So over here, can you tell me if circumcenter is the midpoint of the hypotenuse, what is the circumradius? The circumradius would be how much? Can somebody tell me what is the circumradius in this case? Circumradius, not in radius, circumradius. C by 2, correct Sonima. So if C is the hypotenuse, circumradius will be C by 2. What would be the in radius? There is a direct formula for the in radius. What is the formula for the in radius in this case? You guys have already gotten it. What is this formula for the in radius? C by 2 is the formula for the circumradius. Half of the hypotenuse is the circumradius. The in radius is the sum of the two other sides minus the hypotenuse divided by 2. So here it will be A plus B minus C, the whole divided by 2. This would be the in radius. Okay? Okay. Now can you tell me what is the median to the hypotenuse? What would be the length of the median to the hypotenuse? What is the length of the median to the hypotenuse? See this point, circumradius is the center of the circle. Okay? If I draw this, BC is the median. What would be the length of BC in that case? What is the length of this median? This is C by 2, this is C by 2, which is half of the hypotenuse. So the length of the median where the right angle is there to the hypotenuse, this length median to the hypotenuse, this length is also C by 2. Remember this is an important formula to remember. Okay, correct. Many of you guys got it, Nitin. So remember the formulas for circumradius, in radius and median to hypotenuse for right angle triangle, circumradius, altitude, in radius for equilateral triangle. Direct application come for all of these. Okay, so I will give some questions on this and Maruti will be here to help you with these parts.
Okay, hi guys. This is not a difficult question. This is an interesting question about angle bisectors, which I would think is an important concept. So the timer is there. I think I gave maybe around 2 minutes for this question. It's not a very difficult question. I hope you get it correct. Let's see. Some people might be wondering that why did we give lesser time? The reason for lesser time is first, the questions are not very difficult. Some of the questions are actually pretty simple. And I also wanted to solve more questions. This will anyways be a long stream, so I don't want to make it extra long. That is the reason I gave slightly lesser time. Good afternoon, Sonal. Like always, the target for this stream also is 300 likes. And we have 94 likes, so we need to get to another 206 likes before the stream ends. Do let me know if you prefer red or you prefer white for writing. Normally I would want to switch to white. So let us see. I'll explain this question in white. Sayali was explaining it in red. So let me know which of the two you would prefer. Yeah, Mahesh got it correct. Priyal, think again. Try again. Sarthak also got it correct. Many people got it correct. Some people I think didn't get it correct, but try it out. There is still like 40 seconds left. Good evening, Sumit. Yeah, many people, Shreyas also got it correct. Let's see. Nasi Dubey Singh. Ma'am, on a daily basis, I'm doing 50 to 70 questions. In Quant 5-6 sets in LRDF, in daily, should I increase to 7 to 8 sets? I'm getting 50 to 60 marks in overall. How should I take it to 90 plus? I think Nasi, I think you're doing a very good job. If you are attempting 50 questions in Quant and say 5 or 6 LRD sets, I think you are definitely on the right track. Just ensure that you are covering all the different topics in Quant. Just don't do one particular topic. If you are solving 50 questions, try to make it say 20 from arithmetic, 15 from algebra, 15 from geometry, maybe some questions in number systems, modern maths, those kind of things. If you are giving a wide variety of questions, it will always be very beneficial for you. Okay guys, the time is up. Let us try to answer this question. Yeah. So in this question we are told that M is the incenter of a triangle PQR. The angle PQR is 80 degrees. We are required to calculate the value of the angle QMR. In geometry, I always recommend you to first draw the diagram. Once you draw the diagram, you will get an intuitive sense of what exactly is asked, and then you can answer it faster and you will also be more accurate. So here first draw a triangle PQR. This is the triangle PQR. It looks something like this. This is P. This is Q and this is R. We have M over here. This is the incenter. What is the incenter? Incenter is the point of intersection of all the angle bisectors of the triangle. So if you join Q to M and you join R to M, these two are the angle bisectors. So if this angle is A, this angle also is A. If this angle is B, this angle also is B. We are given angle QPR. Angle QPR is 80 degrees. So this over here is 80 degrees. Now we know the sum of all the angles of a triangle. The sum of all the angles of a triangle is 180 degrees. This would imply that this A plus this A, which is 2A, plus this B plus this B is 2B, plus 80 degrees is equal to 180. This is sum of all the angles of triangle PQR, or 2A plus 2B is equal to 100 degrees, or the value of A plus B is equal to 50 degrees. Why did we calculate A plus B? Because if you are looking at triangle QMR, this angle, that is angle QMR, plus this A plus this B also have to be equal to 180 degrees. That is angle QMR plus A plus B is equal to 180 degrees. Now we know that A plus B is 50 degrees. We just calculated that. So this has to equal 50 degrees, or the value of angle QMR will be equal to 130 degrees. So the answer for this question is option A. Let me look at what people have said in the chat, and after that we'll go to the next question. Okay, many people I think got it correct. Viren Talwar, Ayush Shandilya, Aryan, Ishita, the boss, all of these guys have gotten it correct. Mukundaga asked, Sayali ma'am, can we have an entire mock live attempt instead of just sectionals? I know that is interesting. The thing is, an entire mock attempt is a 2-hour attempt. So we are trying to figure out what is the time during which we can actually do it. We are thinking about it, we will let you know. Okay guys, let us look at the next question. This also is an interesting question. I think I gave 2.5 minutes for this. So try to solve it guys. Supraja is saying, sir, it's difficult to get back into a completed concept and eventually forgetting them and finding it difficult to touch the entire section, especially quants. How to stay consistent? What I would tell you is, the first time you finish a concept and say you leave it for some time, then after a week or so you will feel that, okay, I have forgotten this. But the next time you revise it and after 1 week, you feel that you have remembered more. So basically what I am essentially saying is, once you study a concept, revise it once or twice after a gap of say 2-3 weeks, then you will remember that, you will realize that you are remembering much more. Initially, if you just review a concept and don't revise it, you might forget everything in 2-3 weeks. But if you revise it once, most of the things you will remember and you will understand them, and even after a week or two, you will remember some of them. If you revise again, the next time you don't forget as much. So the whole point is revising regularly, and also you have to remember that when you are revising regularly, you will retain more of the information. Kushal Sagar Kumawat. My marks in VRC and DLR are around 20 and in QA I am scoring around 30. I want to improve in VRC. I get scared looking at the length of the passes. How to get over it? Basically what I would tell you is, in VARC, people are very worried that, okay, my reading speed is bad, but VRC also is a point of logic. It is not just your vocabulary or anything, you have to understand, but a different type of logic. Basically the paragraphs that are given in CAT are very good, they are very well written. So every passage, every paragraph has a purpose. The first paragraph is intended to convey some meaning. The second paragraph also is intended to convey some meaning. And there is a nuance that is involved. Every sentence in the paragraph is thought about and written. There are very few redundant lines in any paragraph. Every line has a purpose. The whole point is, one line to the next line, there will be some connection. That connection essentially gives you the nuance of that RC. That is the logic that you'll have to figure out. If the author is saying certain things, but he is saying something like however or but, why is he using the words like however? You have to understand the implications of those kind of words. That is the whole point of RCs, where you understand what is the importance of each line in the RC. Now, if you read a lot of good articles, you will inculcate that sense and your reading speed also will improve. So the only way in which I would recommend you to improve your score in VARC is by reading a lot of articles on a daily basis. I would recommend you to go to the Cracku reading articles. We update this every day and I am sure it will be very helpful for you. The link for it will be given in the chat, so definitely bookmark it. Again, like I am saying, in this question, first draw the diagram. Once you draw the diagram, you will get a sense of what exactly is given and what exactly is asked. Here we are given a triangle XYZ. The external angle bisector of X and the internal angle bisector of Y meet at W. If angle XZY is 50 degrees, what is the value of angle XWY? So this is basically how the triangle is. This is X, this is Y, and this is Z. The external angle, okay, this is the angle bisector, the external angle bisector of X, this is the internal angle bisector of Y. Let us assume that both of them are meeting over here. This is W. Now, what are we given? We are given angle XZY is 50 degrees. This we are told is 50 degrees. And what are we required to calculate? We are required to calculate angle XWY. We are required to calculate this. This is what we are asked to calculate. YW is the angle bisector of Y. So let us assume that this is A and this is A. Both of them are the same. So essentially angle Y is 2A. So what is the value of angle YXZ? In the triangle XYZ, there are three angles. One of them is 50 degrees, one of them is 2A. So the third angle will be 180 minus 50 minus 2a, which is equal to 130 minus 2a. So this is 130 minus 2a. Now what about, say, let us assume that this is, say, another a. What about angle AXW? AXW is the exterior angle of angle x. This is 180 minus 130 minus 2a, which is equal to 2a plus 50. And this is bisected by XW. This whole angle is 2a plus 50. So each angle will be a plus 25. This is a plus 25 and this is a plus 25. I am unable to, okay, a plus 25, okay. Now if you are looking for to calculate angle XWY, you have to just look at the triangle XWY. One of the angles is this, which is A. One of the angle is 130 minus 2a plus a plus 25. So that is 130 minus 2a plus a plus 25. So the sum of these two angles, if you see, is equal to 155 degrees. Therefore, the third angle, the value of the third angle will be 180 minus that, which is 180 minus 155, which will equal 25 degrees. So the answer for this question is option D, which is 25 degrees. Let me look at the chart, and after that we'll go to the next question. Okay, I think people are fine with this question, so let us go to the next question. Okay, this is an interesting question. I'll lift this up, so I hope you can see it. So basically ABC is an equilateral triangle. Maybe I'll put it this way. Okay. Yeah. Let me know if you are able to see it and if you are able to understand it. Basically, we are given an equilateral triangle ABC. You are given an in circle like this. You are given another circle at the top. What we are required to calculate is the ratio of the area of the smaller circle to the area of the larger circle. We are basically asked to calculate the area of this circle to this circle, the ratio. That is what is asked. I'll keep it like this so that people can look at it. Sir, I am only able to attend 15 questions at max in VRC and scoring 15 to 20 each time. What should be the exact amount of questions I should attempt in VRC? I want to make it clear to everyone. If you are aiming to get into a top 10 college, you have to attempt all 24 in VRC. If you are very serious about getting into a top institute, you have to attempt all 24. Now, I am not saying you have to get all 24 correct, but the strategy of only attempting 15 questions or 16 questions is a very bad strategy. If you are attempting 15 questions with say 70% accuracy, I would say attempt 24 questions with 60% accuracy. Let your accuracy come down, but attempt all. Just focusing on 15 questions is a terrible strategy because you are leaving 9 questions. Even if you are attempting 16, you are leaving 8 questions. It makes no sense. It's a very inefficient strategy. I would recommend you to attempt all the 24 questions. Even if your accuracy falls, it's fine. If you are feeling that, sir, but my reading speed is not good, I would just tell you it is okay if your reading speed is not good. Read faster, put a time limit for each RC, attempt and go to the next one. It should not happen that you are leaving 8 questions out of 24 questions. That is just extremely bad and very inefficient strategy. Okay guys, how many likes did we get till now? I think we got 108 likes. Guys, we need 192 more likes. We can do it guys, 192 more likes. Please do like the stream. We have 140 people who are watching the stream live. I need some more likes. If there are more likes, then people will be more motivated. My team also will be more motivated in conducting this kind of sessions regularly. This is a Saturday, but some of my team members are actually working to ensure that this stream is actually going live. So the only way in which we can actually thank all of them is by giving a like for this stream so that they also know that whatever we are doing is being appreciated by the students. Now I know that people appreciate it, but if you give a like, many of my teammates also feel more motivated. Okay, time is up. Let us try to answer this question. So basically what we are asked to calculate is, we are given a triangle ABC. This is an equilateral triangle. Two circles are inscribed as shown in the figure. We are required to calculate the ratio of the area of the smaller circle to the area of the larger circle. This seems like a complicated question, but this is not a very complicated question. Why exactly is this not complicated? Because this kind of a question is often asked. Let us first draw a line. Let me use the black color if it is there to draw the line. Okay, wait. Okay, I don't think I have a black color line, but let me use a red colored line to draw. Let us assume that I am drawing a line which is a tangent to both of these circles and it passes through the point of intersection, something like this. Let me draw it again. I am not super good, but let me draw it this way. Okay, let us assume that this is D and E. Now one thing we have to notice is ADE also, I'll come back to white. ADE is an equilateral triangle. Just by symmetry, ADE is an equilateral triangle. DE will be parallel to BC. Now what we need to calculate is the smaller circle is the in circle of ADE. Similarly, the larger circle is the in radius, is the in circle of ABC. So basically the smaller circle is the in radius of the in circle of the smaller of ADA. The larger circle is the in circle of the triangle ABC. If you are asked to calculate the ratio of the areas of the circles, if you assume that this radius, is small r1 and this radius is small r2, what we are asked to calculate is pi r1 square by pi r2 square. This is what we are required to calculate, which is basically r1 square by r2 square. This is the ratio we need. Essentially we need the ratio of the squares of the in radius. But we know that for any equilateral triangle, the in radius r is equal to a by 2 root 3. So what we are essentially asked to calculate is, because the in radius varies directly in proportion to the side of the equilateral triangle, we are basically asked to calculate a1 square divided by a square, where a1, where the side of the small, where the side of ADE, this is a1 and this side of ABC is a. We are required to calculate the ratio of those two sides and square it, and that will be the answer. How can we do it? Now let us draw a altitude from here which will pass through these points. Let this be say F and let this be G. So what we are required to calculate is the ratio of the sides is also equal to the ratio of their altitudes of any equilateral triangle. The ratio of any two equilateral triangles, the ratio of the altitudes is the same as the ratio of the sides. So essentially what we are required to calculate is AG by AF. AG is the altitude of the smaller equilateral triangle, this one, and AF is the altitude of the bigger equilateral triangle. If we can calculate this and square it, we will get the answer. And then we can figure out that it is not very difficult. How can we know that? Because we know the length of AF. AF is the altitude of the larger equilateral triangle. This will be equal to a root 3 by 2. GF is the diameter of the in circle. GF is equal to a by 2 root 3 into 2. A by 2 root 3 is the in radius, but GF is not the radius, GF is the diameter of the in circle. So multiply it by 2, we are going to get the length of GF, which is equal to A by root 3. The difference between both of them is the value of AG. So AG is equal to A root 3 by 2 minus A by root 3. We can simplify this. This is equal to by 2 root 3, 3A minus 2A, which is A. This is the value of AG. What we are required to calculate is AG divided by AF. AG divided by AF will be A by 2 root 3. This is AG divided by AF. AF is A root 3 by 2. This ratio you can remove by 2, which is in the denominator. We can cancel A. This is basically 1 by root 3 whole square, which is 1 by 3. So the value of AG divided by AF, this ratio is 1 by 3. What we are required to calculate is the square of this ratio, which is equal to 1 by 9. So the answer for this question is 1:9. Is there the options? Yeah. So the option will be option C. Just to reiterate, what we have done is very simple. What we have done is we have realized that ADE is an equilateral triangle, ABC is an equilateral triangle. We know that the smaller circle is the in radius, in circle of the smaller equilateral triangle. The larger circle is the in circle of the larger equilateral triangle. If we are asked to calculate the ratio of the areas of these two circles, we have to essentially calculate the square of the ratio of their radii. But their radii will be directly in proportion to the side of the equilateral triangle. Remember that for any equilateral triangle, the in radius is A by 2 root 3. So if we can calculate the ratio of their sides, we can easily calculate the required ratio. The ratio of their sides also is in direct proportion to their altitudes. If you are given any equilateral triangle like this, this altitude H is equal to A into root 3 by 2. If A is the side of the equilateral triangle, the altitude is A into root 3 by 2. So if you are required to calculate the ratio of their altitudes and the ratio of their sides, both of them are the same. Here we can calculate the ratio of their altitudes very easily. AG is the altitude of the smaller equilateral triangle. AF is the altitude of the bigger equilateral triangle. We know the value of AF. AF is equal to A root 3 by 2 because AF is the altitude of the bigger equilateral triangle. GF is the diameter of the in circle. The radius of the in circle is A by 2 root 3. So GF will be twice that, which is equal to A by root 3. The difference between these two is AG, which is equal to A by 2 root 3. The ratio of their altitudes therefore is 1 by 3. So the square of the ratio of their altitudes, which is what we are required to calculate, is 1 by 9. Let me look at the chat and after that we'll go to the next question. Yeah, I think many people got it correct. CAT registration is extended till 1 week. But don't wait for the last day, guys. Try to just register of either today or tomorrow. Don't wait for the last day. It is not a good habit. Trying to register early, I think, will be better. Mukunda Singh, sir, in your VRC dash cat attempts, you finish the section in 40 minutes. How can you do that too? Basically, I'm very, very strict about the time I take for any RC. Sometimes I feel that I didn't read the RC properly, but I feel that it's okay. I might mess up one RC or my accuracy might decrease, but it doesn't mean that I have to read the RC multiple times. So I'm very, very strict about the times. For example, I know that I attempt first 2 RCs and then I attempt 4 VA questions. Then I attempt the third RC and then I attempt the remaining VA questions and then I'll finally attempt the last RC. This is my strategy and this is my pattern, which is I follow in every dash cat. First 2 RCs, then 4 VA questions, then the third RC, then the remaining 4 VA questions, and finally the last RC. I know at every stage how many minutes have to be left. After the first 2 RCs and I'll have around say 25 minutes left. Then after the first 4 VA questions, I should have exactly 20 minutes left. If I am falling behind for whatever reason, I ensure that I go faster so that my accuracy might fall, but it won't happen that I didn't attempt an RC or I had like say 3 minutes for an RC. That won't happen. The time is in my hands. The accuracy is not in my hands. I try to keep the accuracy as high as possible, but I would ensure that time, I don't take more time than I have allotted for any RC or any VA question. Okay, we got 136 likes, very good guys. So we just need another 164 more likes. This is a very simple question. Let us try to get it done. The time is up. We have 120 people who are watching the stream live. Please do like it, guys. If anybody didn't like it, please do that favor for me. My team really looks at the number of likes and they feel very motivated by it. A triangle whose sides are in the ratio of 3, 4, 5 has in radius r and circumradius capital R. Find the value of n if r is n% of capital R. If you are given the three sides which are in the ratio of 3:4:5, let us assume that the sides are 3k, 4k and 5k. What you have to immediately recognize is that 3, 4, 5 is the Pythagorean triplet. Why is that the case? Because 3 square plus 4 square is equal to 5 square. This is something that I would recommend you to remember, because 3 square is 9, 4 square is 16, 5 square is 25. 9 plus 16 is equal to 25. So whenever you have three sides which are in the ratio of 3:4:5, that triangle will be a right angle triangle. So the triangle will be something like this. This will be 3k, this will be 4k, and the longest side, which is the hypotenuse, will be 5k. So what is the in radius of a right angle triangle? In radius is sum of the non-hypotenuse sides minus the hypotenuse divided by 2. So that will be 3k plus 4k minus 5k divided by 2. This is equal to 7k minus 5k, 2k divided by 2 is k. And what is the circumradius? The circumradius of any right angle triangle will be basically the half the length of the hypotenuse, which is 5k by 2. So what is small r divided by capital R? Small r divided by capital R is equal to 1 divided by 5 by 2, which is equal to 2 by 5, which is equal to 0.4 or 40%. Here we are required to calculate it in percentage, n%. So the value of n will be 40. Okay guys, let us now look at the next slide. If you have any doubts in this, let me know in the chat. I think many people got it correct. Before I hand it over to Sayali, I wanted to tell you about the free materials that are available on Cracku. Many students ask us, sir, what are the free materials that are available? I would say there are a few things which I think are extremely good. There are 3 free mocks that are given by Cracku. All of them are in the latest pattern of CAT. They are very similar to CAT 2024. All of them have detailed video solutions and they are taken by thousands of students. These free mocks you can take in cracku.in/cat mock test. The link for it is given in the description of this video. In addition to it, many people ask me what is the best place to start their LRDA preparation. I would say to start the LRDA preparation, go to the previous papers page of Cracku. Again, the link for it is given in the description of this video. Download these PDFs. The PDF of CAT 2024. This is the first thing. There are 3 slots. Download the PDF and try to solve the LRDS on your own. In Cracku, there is also a link for video solution in this PDF. If you don't get an LRDA solution after trying for 30 minutes, 40 minutes, then click on the video solution. You will be redirected to the video solution page and look at the video solution. That I think will be the best step in which you can prepare for LRDA. In addition to it, we have a lot of very useful videos on YouTube. If you are subscribed to our channel, I think you would know this already. But suppose you don't know it, there is a 100 quant question series which we release every year. So there are 5 or 6 videos on Cracku YouTube channel. The link for this playlist is given in the description of this video. Similarly, there is a revision video playlist. This is watched by I think lakhs and lakhs of people. I think every video in this revision playlist is watched by around 5 lakhs or 6 lakhs people. It helps students quite a lot. I would say go to these videos, bookmark this playlist and watch them whenever you get time. These I think are excellent resources. All of them are completely available for free. If you have any doubts, you can ask in the chat and somebody from my team is going to respond to you.
Okay. Okay, so I see some questions that were asked. Mukund saying, sir, mock 2 and 3 are still in old pattern of 3 hours. No, they are pattern of 2 hours only. Maybe there like some text is left over where it is written 3 hours, but it is in 2 hours. Take the CAT free mock 2 and 3. They are in, all of the mocks that are there are in the current pattern. So you need not worry that any of the mocks are in the old pattern. All the 3 free mocks as well as like the previous year's paper are basically in the same pattern as they were in that particular year. But all the mocks, head start mocks, dash cats, free mocks, everything is in the latest pattern. Okay, and one more, somebody asked that, sir, why the name is Cracku? So basically, Cracku was a term that was used in Maruti's undergrad, during Maruti's undergrad at IIT Bombay. So they used to call students who would study a lot or who would put a lot of effort as muggus, and the guys who would put smart effort or like put just the right amount of effort and get the same marks, they would call them Crackus. Cracku being the person who prepares smartly, Muggu being the person who prepares by brute force, like just going through everything and mugging everything up. So that's why we named it Cracku, because we want our students to be Crackus who are preparing smartly. Okay, so let's get started. Okay. Sonima is asking, ma'am, I do a lot of silly mistakes in trying to do the question quickly. How can I how can I avoid the mistakes and increase the speed? Sonima, the only way to avoid silly mistakes is basically that you should have 100% focus. If you feel that you are not focused, if you are in a place with a lot of distractions, that focus, if it varies, then you will end up making silly mistakes. Secondly, the thing that matters is motivation. You have to be very motivated. See, whenever you take any mock CAT, you should be 100% motivated in that mock CAT. If you take it ki arey abhi karna hai and I'll try to do as well as I can, then that motivation will not be there. I also know, Sonima, you take a lot of mocks, so that also might be a reason where you are not super motivated in each mock, because if you have taken a lot of mocks, that motivation level per mock might be lesser. The third reason is basically practice. The more you practice, the more in the zone you will be. See, silly mistakes basically occur whenever your chain of thought or concentration is broken. So you can either train yourself to stay concentrated for longer by practicing more, or each mock should matter so much that you're fully invested in it, that you don't get distracted and you don't end up making a mistake. These are the only 3 areas which you have to focus on: concentration, focus, and motivation. You have to be fully motivated to do well in the mock. If your motivation level is lower, right, it can reduce your scores by at least 10-20%. Okay, so let's go to the next part, which is the midpoint theorem, basic proportionality theorem. These have a wide application in all triangles based questions. Whenever you see triangles based questions, wherever there is ratio of areas mentioned, wherever there is parallel lines mentioned inside the triangles, you have to think of these, because these two are like the they will supercharge your answers, finding of answers inside triangles. So what is the midpoint theorem? So midpoint theorem is basically, if you have a triangle like this, and suppose D is the midpoint of AB, E is the midpoint of AC, if you join the line DE, it will be parallel to BC. And this line DE will be half the length of BC. See, this is half length, AD is half of AB, AE is half of AC, so DE will also be half of BC. In general, you should remember that whatever line you draw, which is parallel to the base, it will cut each side in the same proportion. So basically, if I say that this is like, if I draw a line ABC, if I draw a line like this over here, such that this is 2/5 of the whole line, say 40%. So this is 2x, this is 3x, and this is also 2x and say 2y and 3y. It is cutting the line in the ratio 2:5, for example. It is parallel to the bottom. Then everything in this will be cut in the same ratio, which means that the altitude will also be cut in the same ratio. That if AD is the altitude, this will be 2z and this will be 3z. The whole altitude will also be cut in the ratio 2:5. This, say if this is DE, DE will also be 2/5 of BC. So always whenever you join midpoints, this line will be parallel to BC. The line, this part will be half. But midpoint theorem is basically a subset of the basic proportionality theorem. Basic proportionality theorem is that if you draw a line which is parallel, that parallel line splits everything in the same proportion as the points it is joining. So if D is parallel to BC and AD to AB is 2:5, then AE to AC will also be 2:5, and DE by BC will also be 2:5. It basically proportionally cuts every part. So base will be 2/5, the side will be 2/5, this side will be 2/5, the altitude will be 2/5. So everything you can consider that it creates a miniature of the same triangle, which is 2/5 in each dimension. And if it is 2/5 in each dimension, what would be the ratio of the areas? If it is 2/5 in base, if it is 2/5 in altitude, then what would be the ratio of the areas as such? Can somebody tell me? Can somebody quickly tell me if, yes, 4/25. See, basically if you are joining, you are right, okay, 4/25 is the correct answer. See, if you have A, B, C, okay, and this line is parallel, okay, and it is cutting in the ratio A is to B, okay, this will also be A is to B, and this will be A is to A plus B. It will not be exactly A, it will be in the same ratio. But because it is cutting in the ratio A divided by A plus B, the area will be in the ratio A square divided by A plus B the whole square. Why square? Not why is the ratio of areas not A is to A plus B? Why is it not in the 2:5 ratio only? Why is it like 2 square by 5 square? Because area is half into base into height. Height is basically altitude. Your base becomes 2/5, your height also becomes 2/5. So 2/5 into 2/5, it becomes square of 2/5. So it becomes 4/25. So always remember, if your ratio of the sides is in the ratio A is to B, okay, there are two triangles such that this is a miniature of the other triangle, and the ratio of the sides is A is to B. The ratio of the areas will be A square by B square. In basic proportionality theorem, remember that whenever a parallel line cuts a line parallel to the base, it cuts it in the ratio A is to B. It will cut every side in the ratio A is to B. It will cut the altitude in the side ratio A is to B. It will cut this, the base, new base will be in the ratio A is to B. That is A, okay, I'll just do it again because there will be like some confusion. Suppose this is the ABC and this is any parallel line DE such that this part is A and this part is B. That is AD by AB is A is to B. Then basically ADE is a miniature version of ABC. Every single corresponding side of ADE will be in the ratio A is to B. So this by this will also be in the ratio A is to B. So AE by AC will also be in the ratio A is to B. DE by DC will also be in the ratio A is to B. This comes, and if say A is to B is 1:2, suppose if it is 1:2, then D becomes the midpoint of AB, then you get basically the midpoint theorem. So midpoint theorem is like a subset of basic proportionality theorem. Basic proportionality theorem is if DE is parallel, then everything will be in equal proportion. That is, every part of the triangle will be cut in the same proportion. Okay. Let's consider the next theorem. These theorems come much more often. Basic proportionality theorem will not come as it is. It will basically be considered as part of something else, where a parallel line will be given. Then you have to say that, okay, based on basic proportionality theorem, I can say that the remaining sides are this. Basic proportionality theorem alone will not come, but these two things alone often come. So whenever you are given any triangle, okay, and you have A, B, C, and suppose the median is given, and the question is asked about a side, any side, AB, AC or BD or AD also, anything is given, immediately you should think of Apollonius theorem. For Apollonius theorem, you need median, okay, and anything which involves side or length of side is required. You should think of Apollonius theorem. What is Apollonius theorem? Apollonius theorem basically says that AB square plus AC square is equal to 2 times AD square plus BD square. Here BD and DC are equal, so you can either say BD square or DC square. Why does this come? This basically comes from basically like you can say that you're splitting the triangle into two equal halves. By using the altitude, you can then figure out that, okay, this should be this much, this should be this part. The formula derivation is slightly complicated, but always remember, if you don't remember this formula, if I'm not able to figure out, okay, what is this formula? How do I calculate this formula? Remember that you can always check with a isosceles triangle. In an isosceles triangle, what did I tell you? In an isosceles triangle, the median is also the perpendicular bisector. So in an isosceles triangle, what do you have? This would be the perpendicular bisector. So in this case, AC square will be how much? That will be AD square plus CD square, right? And AB square will be how much? This will be AD square plus BD square. If I add them up, I get basically 2 times AD square plus 2 times BD square or 2 times CD square, which is the same as this. If it is true for isosceles triangle, it will also be true for any other triangle. It is, in this case, it is true for every triangle, not just isosceles triangle. But if you are like forgetting the formula, if you want to quickly remember, how do I remember? I generally check it by considering an equilateral triangle and an isosceles triangle just to check whether my formula method or formula value is correct or not. Sometimes people forget this too or something else. Don't forget that. If you are forgetting the formula, if it doesn't come back to you, check it against a isosceles triangle. So always remember, the sum of the squares of the two sides of the triangle is the sum of 2 times the sum of the square of the median length and half the base of the triangle. Okay, so this is the Apollonius theorem. Whenever median is given, think of Apollonius theorem. When should you think of angle bisector theorem? Whenever angle bisector is given, you should think of angle bisector theorem. Simple enough. So what is angle bisector theorem? Consider a triangle like this, ABC. Suppose we have an angle bisector of angle A. Suppose AD is the angle bisector of angle A. Now according to angle bisector theorem, AB by AC is equal to BD by DC. DC. What does this mean? This means that the angle bisector bisects, or the angle bisector rather splits the opposite side in the same ratio as the two sides of the triangle. So if this is X, this is Y, then this BC will also be split in the ratio X is to Y. So this will be X times K and Y times K. Why? Basically think of it in this way, that the triangles that you are forming, this triangle that you are forming, whatever is this value, say X X I have already used, suppose this is alpha, okay, and this is alpha degrees, okay. Whatever is this value beta, this will be 180 minus beta. There will be like some other angles which are involved. By similarity of triangles, then you can show that this ratio should be same as the ratio of the sides of the original triangle. So always remember, whatever angle bisector you have, okay, the angle bisector splits the opposite side in the same ratio as the two containing sides. So if this is in the ratio, if AB is to AC is X is to Y, then BC will also be split in the ratio X is to Y. Okay. Any questions, any doubts about this? There are similar triangles, yes. DE by BC is equal to how much? DE by BC where? DE by BC in the basic proportionality. DE by BC will basically be, see, if you have basic proportionality, AD by AB will be same as AE by AC, which will be equal to DE by BC, okay. This ratio will be constant throughout in basic proportionality theorem, okay. Could you also please explain external angle bisector? I always get confused in that. See, the external angle bisector doesn't often come, but the concept there also remains the same. That is that the external angle bisector, still it is the same concept, that it will also continue to divide. Basically think of it in the same way that, okay, let me show that. It continues to divide it in the same ratio. Okay, see, this is the external angle bisector, okay, and whatever is the ratio in which it divides, say this is ABC, So basically the angle, external angle that is there, it will divide the whatever area suppose it intersects over here. Okay, suppose this is M. This basic external angle bisector will also still be in the same ratio. That is whatever, even if you consider the external angle bisector also. So again over here AB by AC will be in the same ratio in which it bisects the external angle. So it will be basically BM by CM. So if you have whichever is the longer side, it will basically, the longer the containing side, the longer the base length would be. So again it will be bisecting in the same particular ratio as such. Okay. So essentially whether it is interior angle bisector or exterior angle bisector, the ratio doesn't change, the formula doesn't change. Just the point of intersection would either be internal or will be external. But either way the formula remains the same. Okay. Let's go to the next part, which is similarity and congruency. Many of the formulas that I was just discussing come from the idea of similarity and congruency. So because of using similarity, most of these theorems are taught. So what is similarity, what is congruency? Consider two triangles. Suppose I have A, B, C. Okay, and suppose this is D, E, F, and suppose this is M, N, O. Okay, now suppose that angle A is equal to angle D is equal to angle M. Angle B is equal to angle E and is equal to angle N, and angle C is equal to angle F is equal to angle D. Okay, if this is the relationship as such, all of these three triangles have the same angles. All interior angles for both of these triangles are similar, same, identical angles as such. Now it might be that you are not given it in the exact same order. Sometimes what is given is that you are given A, B, C like this, and D, E, F is in the other order. So suppose this is D, E and F, and you are given that okay, this F angle is same as A, this B angle is same as D, and this F angle is same as C. So it is given slightly twisted or slight mirror image is given. But irrespective of that, when three angles are equal, when you have three angles of a particular triangle being equal to the three angles of another triangle, you can say that the two triangles are similar. So here I can say that ABC is similar. What is it similar to? See, angle BAC is equal to DEF. So A corresponds to E, B corresponds to D, and C corresponds to F. Now I have to check whether it is FDE or EDF. Both are possible. So I have to basically check that ABC is EDF, yes. BCA is DFE, yes. And CAB is FED, yes. Angle wise if I check, and if the angle, each angle combination is same, then I have got the right order of the letters. Writing the letters in the correct order is super important, because just if I say that okay, ABC is similar to DEF, if I get the order of the letters also wrong, then the further formulas that come, they will also be wrong. So whenever you are also deciding for the similarity, once you realize the triangles are similar, the angle should match. So if A is equal to E, so if I write A over here, I have to write E over here. If I write B and I know that B angle is equal to D, then if I write B over here, I have to write D over here. And C is equal to F, then if I write C over here, I have to write F over here. They have to be in a specific order. So this particular tilde sign indicates that these two triangles are similar to each other. Now if I know that they are similar to each other, what can I say? What can I use about this? So I can say that AB by ED will be equal to, that is this first two letters length, this will be equal to BC by DF, so this two letters, and this will be equal to CA by FE, that is over here. So this is basically the ratio of corresponding side. AB I consider AB and DE. I consider BC and I consider DF. I consider CA and I consider FE. So ratio of the corresponding sides will be equal for similar triangles. How did I check for similar triangles? I checked that all three angles were equal. Whenever three angles are equal, it is called as the AAA test for similarity. This is the most common test. If you consider test for similarity and congruency, for similarity, the most important test, which is the most useful test, is the AAA test, also called as the AA test, because if two angles are equal, by default the third angle will be equal, because the third angle has to be 180 minus the sum of these two angles. So AA test of similarity is the most important, most useful test for similarity. You have to check whether two angles are equal. If the two angles are equal, write the equal angles in the correct order. Then you get that the ratio of their sides is equal. Now consider these triangles, okay? If I consider ABC, DEF and this MNO. I am saying that even MNO has the same angles as ABC. So are they similar triangles? Yes, they are similar triangles. So ABC will be similar to MNO. Now if I add another dimension to it, that not only equal angles, but say AB is equal to say, in this case AB is equal to say ED. If I say that they are equal by length also, not just by angle, they are equal in length also. If there is equality of angles and equality of lengths also, then they have something which is called congruency. So in this case, I will say that ABC is congruent to EDF. What does congruency means? They are equal in shape and size. Similarity means they are just same in shape. In this case, you can visually see that MNO is larger or greater in size than ABC. So it is equiangular, it has the same angles, it has equal angles, but it does not have equal sides. So here you can say that ABC and MNO are similar triangles, but ABC and DEF, because the sides are common, sides are same in length, you can say that they are congruent triangles. The tests for congruency are multiple. There is SSS test. If all three triangles have the same sides, okay, all three sides are equal, then it's these two triangles will be congruent. You can also have SAS test, two sides and the included angle, or even SAA test. In general, if two angles are equal and one side is equal, then it has to be congruent. Why? If the included side is equal and two angles are equal, then it has to be equal, because basically with two angles you establish similarity, and if you show that okay, AB by ED, these two sides have to be in the same ratio, and you show this ratio to be 1, then everything becomes 1. That's why it becomes congruent. So these are the tests for congruency. More than congruency, of practical importance to CAT is similarity. So I want you to know similarity very well. In our basic proportionality diagram, we did similarity essentially. Consider A, B, C, right? And you have D, E over here. And this was parallel, right? Why was it that it was always dividing in the same ratio? Why was each side being divided in the same ratio? Because of similarity. Because once you have these parallel lines, these are corresponding angles of parallel lines. So they will be equal. This is also equal because they are corresponding angles of parallel lines. And this angle is common. So by AA test, you can know that this is similar triangles. If they are similar triangles, their sides will be in the same ratio. So AD by AB will be in the same ratio as AE by AC, will be in the same ratio as DE by BC. Okay, because whenever there is any line which is parallel to one of the other sides, you are getting similar triangles, and once you have similar triangles, you can establish a ratio or like a proportionality between the sides. Okay, so this is basically similarity. Similarity is super useful. I want you guys to know it very well, and always remember, when angles are equal, whenever you can see repeated angles, the first thing that you should look for is similar triangles. Whenever there are repeated angles, x degrees over here, another x degrees over here, figure out the triangles involved and see whether they are similar, because similarity of triangles will help you tremendously in this particular subject. As I mentioned, the ratio of whenever two triangles are similar, the ratio of their lengths will be, suppose ABC is similar to DEF, then the ratio of their lengths taken two at a time, so AB length divided by DE length, this will be equal to BC length divided by EF length, will be equal to AC by DF. So this is some say constant of proportionality K. That is like say in the earlier example I had considered 2:5 ratio. So each length, each ratio will be 2:5. If the ratio of the lengths is k, okay, if the constant of proportionality over here is k, what would be the constant of proportionality of the ratio of their areas? That would be k square, okay. K square, because base also is in k ratio, the height is also in k ratio, so area will be k square ratio, okay. Let's go, and there are some examples and Maruti will be helping you with them.
Okay guys, this is the first question. I'll be doing a lot of questions now. Slightly lengthy question, try to answer it. I gave 3 minutes for this, and in the meantime I'll be taking any questions that you guys might have. Please do like the stream guys. We have I think around 160 likes, so 140 more likes needed. Let me look at any of the questions that you guys might have in the meantime while you guys are solving this question. Afternoon ma'am, I'm going ahead with the schedule you provided in YouTube for 3 month strategy, but falling behind in revision. When revising arithmetic, falling short in arithmetic and in geometry and so on, what to do? I would say don't worry about these kind of things. I think you still have around 2.5 months left. Try to make the best use of it. Even if you seem to be falling behind, maybe you'll have to put in some more effort. The point is, time right now is very limited, so try to make the best use of it. If you feel that okay, I have a job and I have to go to work every day, try to cut down on something else. Try to maybe not go out for any social gatherings, or try to see if you can wake up early. Try to maybe cut down on your phone. There are multiple ways in which you can try to extract say 1 or 2 hours extra and spend it on your studies. Please do like the stream guys. We have 164 likes. We need 136 more likes. There is 50 more seconds to solve this. We need to use Apollonius theorem for it. That is the clue I'm going to give you. And let us see how many people actually got it correct. I don't think anybody got it correct, which is interesting. Try to solve it guys. I know it's a tricky question, but I'm trying to see who is going to get it first. Yeah, Priyal Gupta got it correct. Very well done, Priyal. It was a lengthy question, right? I think it took close to 3 minutes for even the first student to actually post the correct answer. Okay, the time is up. I think only one person posted the answer, which is interesting. So basically, again, let us try to see what is the information that is given to us. The information that is given to us is that this is a park which is there in the form of a right angle triangle, and the length of the longest side is given, it is 80 meters. The mayor of the city constructed 3 paths from the opposite side to the longest side, such that the 3 paths divided the longest side into 4 equal segments. Determine the sum of the squares of the lengths of the 3 paths. So let us assume that this is the park. Let this be A, let this be B, and let this be C. We are given the length of AC. AC is given, the longest side is equal to 80 meters. So from B, we drew 3 lines such that they divided the longest side into 4 equal parts, something like this. If you can, let this be D, let this be E, and let this be F. Now AE is equal to 20, EF is equal to 20, DF is equal to 20, and FC is equal to 20. This would immediately tell us that D is the midpoint of AC. So basically D is the midpoint of the hypotenuse. Just give me 1 second guys, I'll try to get a new pen. Okay. Now D is the midpoint of the hypotenuse, so D is the circumcenter of the circle. Now what is the length of BD? BD will be equal to the circumradius, which is equal to just give me 1 minute. BD is equal to 40 meters, because BD is the circumradius. Know that in a right angle triangle, the midpoint of the hypotenuse, this point will be the circumradius. So AD is equal to CD is equal to BD, which is equal to 40 meters. Now using Apollonius theorem, we can calculate the length of the side BE, and we can calculate the length of BF, and then find out the squares of the three sides. Okay, here's the point. In Apollonius theorem, suppose we are applying it in triangle ABD. If this is the triangle you are applying Apollonius theorem in, then AB square plus BD square is equal to 2 times BA square plus ED square. Note that BD square we know it is equal to 40. So essentially this equation says that AB square, which we don't know the length, AB square plus BD square is 1600 is equal to 2 times BE square plus ED square is 400. Similarly, if you apply the Apollonius theorem on the triangle BDC, BC square plus BD square, which is 1600, is equal to 2 times BF square plus 400. If you add both of this up, what is AB square plus BC square? AB square plus BC square plus, this is not 1600 square, this is 1600, 3200 is equal to 2 times BE square plus BF square plus, that is 800, and this is another 800, so plus 1600. Now AB square plus BC square will be 6400. Why is that the case? That will be 6400 because the length of this is a hypotenuse, and AB square plus BC square is equal to AC square. We know the length of AC is equal to 80. So AC square will be 6400. So 6400 plus 3200, which is 9600, is equal to 2 times BE square plus BF square plus 1600, or BE square plus BF square will be equal to 4000. What are we required to calculate? We are required to calculate BE square plus BD square plus BF square. We know the length of BD. BD is equal to 40 meters. Therefore, BE square plus BF square plus BD square is equal to 4000 plus 1600, which is equal to 5600. So the answer for this question will be option C, 5600. Let me look at the chat, guys, and after that I'll go to the next question. I think many people got it correct, 5600. Okay. Devansh Gupta is saying, can we solve this question using arithmetic progression? The 3 paths will be in AP, right? Why would they be in AP? How can you say for certain that they will be in AP? So the sum of the first line and the third line will be twice the sum of BD. From here we can square both sides of the equation. I don't think we can say that the 3 sides will be in AP. At least I can't think of how you can say it obviously. It is not obvious to me that they will be in AP. Calm down is saying, how is BD equal to 40? BD will be equal to 40 because this is the triangle that we have. This is A, this is B, and this is C. BD is the line joining the midpoint of AC to the point B. D will be the circumradius. So AD will be equal to, BD will be equal to CD. All of them will equal AC divided by 2, which is equal to 40 meters. That is because D will be the circumradius or the circumcenter of the triangle. In any right angle triangle, the center of the hypotenuse will be the circumcenter of the triangle. Nitin Chanakya Gundam got it correct. Very well done, guys. Akkoja Venkat Saikiran also got it correct. Sanim also got it correct. Yesh Darji also got it correct. Vikas Chaudhary also got it correct. This is basically applying Apollonius theorem on all the 3 sides. This is an interesting question. Basically, I put this question because I felt that once you solve it, you will understand Apollonius theorem very well and you will not forget it. We have close to 100 people who are watching the stream live. We have 167 likes. Try to get another 133 likes, guys. If we can hit 300 likes, all of us will feel very, very happy. So please do us a favor and please do like the stream if you appreciate the effort we are putting in. How can you say they are bisecting the angle? They are not bisecting the angle, I think they are bisecting the sides. Okay. I think the time is up, guys. Let us try to answer this question. In a triangle, what is the ratio of the sum of the squares of the sides of the triangle to the sum of the squares of the medians of the triangle? Let us assume that we have a triangle like this. This is the triangle ABC. This is A. This is B. And this is C. This is the first median. This is D. This is the second median. This is E. And this is the third median. This is F. This will be the centroid G. Let the length of AD be equal to M1. Let the length of BE be equal to M2. And let the length of CF be equal to M3. They are the lengths of the 3 medians. Using Apollonius theorem on all the 3 sides, on first if you are putting it on M1 to calculate the length of M1, the length of again let's say BC be equal to small a. Let the length of AC be equal to small b, and let the length of AB be equal to small c. What we know is, by using Apollonius theorem, AB square plus AC square is equal to 2 times AD square plus BD square. This basically means that AB square is small c square plus AC square is small b square is equal to 2 times AD square, which is the length of the first median, so M1 square, plus BD square. BD is basically BC divided by 2, so that is A square by 4. This is the first equation that we have. Similarly, we can write other equations. Similarly, A square plus C square will be equal to 2 times A square plus C square will be equal to 2 times the second one, BE, M2 square plus B square by 4. And the third one will be A square plus B square is equal to 2 times M3 square plus C square by 4. If you add all of them up, what are we going to get? if you add all of them up, the left hand side will be 2a square plus 2b square plus 2c square is equal to 2 times m1 square plus m2 square plus m3 square plus a square by 4 plus b square by 4 plus c square by 4. You can cancel 2 on both sides and you are essentially left with 3a square by 4 plus 3b square by 4 plus 3c square by 4 is equal to m1 square plus m2 square plus m3 square. So the ratio of the squares of the sum of the squares of the sides divided by the sum of the squares of the medians will be equal to 4 by 3. This is basically equal to a square plus b square plus c square divided by m1 square plus m2 square plus m3 square. So the answer for this question will be option B. Let me look at the chat and then we'll go to the next question. Many people are asking, is the CAT date extended? Yes, CAT date is extended because I don't know why, but it is extended by a week. Aryan Place is saying, I got the answer by assuming it to be an equivalent triangle. I think that's a smart way to do it. For this kind of a question where options are given and it is assumed, you can assume it to be any one of the triangles and you can get it quickly. This I think is an easy question. I gave only 2 minutes for this. I hope most people get it correct. But let us see who will get it correct first. The earlier question, I think many people got it correct. Mahesh, Naman, Sonima Dwivedi, Vedantika, Vishal Datta, Umang, Srivatsa, all of these guys got it correct. Okay, Vishal Datta got it correct this time. Umang Patel, Akoja, Sai Kiran, Priyal Gupta, Akrit Agarwal. Okay, well done all of you. These kind of questions, if they come in the examination, they should be sitters. You should definitely get it correct within a minute or so. Devesh Gupta, Sonima Dwivedi. And in general in CAT, there will be some questions which are sitters. You have to believe that there will be some questions which are sitters and then you will find them. If you feel that all the 22 questions are very difficult and if you go in with that preconceived notion, even if a very easy question comes, you keep doubting yourself. You keep thinking that, okay, is it really an easy question? You should not go in with that kind of an attitude. You should believe that there will be some questions which are easy and you will be able to get them correct very quickly. Many people got it correct. Vedantika M, Sonal Roy, Yash Darji, Mahesh Khoje, Naman Agarwal are in place. Pratik Purohit is asking a question. I'll answer your question after explaining this question, guys. Okay. In this question, we are told that there is AD, which is the median, and the sides BC are given 4 centimeters, AC is given 8 centimeters, AB is given 6 centimeters. Okay. What would be the length of the median AD? So let us assume that this is the triangle ABC. This is A, this is B, and this is C. AB is given, it is 6 centimeters. AC is given, this is 8 centimeters. And BC is given, this is 4 centimeters. Now if you join A to BC, you are going to get D. This is AD. Now we are required to calculate the length of the median AD. If you are required to calculate the length of the median AD, you will use Apollonius theorem. AB square plus BC square is equal to 2 times AD square plus BD square. Now BC is equal to 4, so BD will be 2, DC will be 2. AB square is 6 square. BC square is 8 square. This is equal to 2 times AD square plus BD square is 4. 6 square plus 8 square is, this is 36 plus 64, this will come to equal 100. 100 is equal to 2 times AD square plus 4, or if you simplify it, you are going to get AD square to be equal to 100 by 2 is 50 minus 4 is 46, or the length of AD is equal to square root of 46. So the answer for this question is option A. Let me look at the chat and then I'll go to the next question, guys. Okay. Pratik Purohit is saying, sir, what do you mean by one should be ruthless in quants? Basically what I mean is, many times when I talk to people, they tell me that in quant, sometimes without looking at the timer, they spend like say 5 minutes, 6 minutes, 10 minutes on a particular question because they feel that this is a question which is easy, or this is a question I made some progress. They feel that, okay, if I spend just another 30 seconds, I'll get it correct, or if I spend another 1 minute, I'll get it correct. In those kind of situations, I tell people to be ruthless. I put a timer, a hard upper limit for myself that every question I should get it correct within 3 minutes. If I'm not getting it correct within 3 minutes, I leave it and I go to the next question, irrespective of how much progress I made. The reason I do that is because I believe that it is very important to not miss out on easy questions just because we did not have the time for it. And I also know that if I finish looking at all the questions and I come back to this particular question later, whatever effort I made or whatever progress I made in that question is still saved. In the sense that, suppose I spent 3 minutes on that question and I come back to it after 15 minutes. It won't mean that within this 15 minutes I completely forgot this question. That won't happen to me. I can sense the question, I know I have read that question, I know the theme of the question, I know the setup of the question. So when I come back to it, I can just take over from there, and many times I get it done very quickly. If I come back and look at that question after spending 3 minutes on it, the next time I have to just spend a minute or 1.5 minutes to actually get it correct. So I don't feel that this 3 minutes is wasted. I just feel that I have spent a lot of time, I don't want to waste more time on it, and I ruthlessly go to the next one. That is what I would recommend you also to do. Don't spend more than 3 minutes on any particular question in the first go. Then you will not be making use of any easy questions that will be there either in the middle or at the end. Okay, many people got it correct. Vishal Datta again got it correct first. Very well done, guys. Sonima Dwivedi, Shilpa Kumari, Vikas Chaudhary, Yash Bandhwa, Akoja Venkat Sai Kiran, Priyal Gupta, Chirag Umag Patel, Akriti, Devesh, Yash Darji, Vedantika, Sonal. All of these guys have gotten it correct. Okay, let us try to answer this question. The time is up. In this question, ABC is a triangle. P and Q are points on sides AC, AB and AC. So let me first draw it. This is the triangle ABC. This is A, this is B, and this is C. P and Q are points on AB and AC. Line PQ is parallel to BC. Okay, this is P and this is Q. PQ is parallel to BC and AP is to PB is 3:4. So if you assume that this is 3A, this will be 4A. The area of the triangle APQ is 18 centimeter square. Okay. APQ is 18 centimeter square. Now one thing we know is that triangle APQ is similar to triangle ABC. Whenever you draw a line which is parallel to the base of a triangle, you get a smaller triangle which will be similar to the bigger triangle. You can easily confirm this also because these two lines are parallel. Angle P and angle B will be corresponding angles, they are the same. Angle Q and angle C will also be same, and angle A is common. So the angles of APQ and the angles of ABC are exactly the same. And what is the ratio of the sides? The ratio of the sides is AP is equal to 3A. What is the value of AB? AB is equal to 7A. Remember that AP is 3A, PB is 4A. So the value of AB is 7A. So we can calculate the area of triangle ABC. The area of triangle APQ divided by the area of triangle ABC will be equal to the square of their ratio of their sides. The ratio of their sides is 3:7. So the ratio of their areas will be square of that. Area of triangle APQ is given. This is 18. Divided by area of triangle ABC will be 9 by 49. If you are simplifying it, area of triangle ABC will be equal to 49 into 2, which is equal to 98 centimeter square. So if area of triangle ABC is 98, APQ is 18, PQBC will be 80. Because the overall area is 98, if one of them is 18, the other one will be 80, which is what we are required to calculate. The area of BPQC will be equal to option C, which is 80 centimeter square. Let me now look at the next question. Okay, guys, if you are not following us on Instagram, please do give us a like. We have hit 47,000 likes recently, and we try to ensure that any update that is there with respect to CAT or other MBA exams, we try to put it up very quickly. We are also putting up very useful information, like recently we put up a list of formulas, different formulas for each of the important topics in Quant. We are also putting up very useful posts with respect to different colleges and their cutoffs. Please do like it. Our Instagram profile is Cracku exam. We have more than 47,000 people who are following us on Instagram. If you are following us on Instagram, please do let me know in the chat. I'll try to give you a shout out. Let us now look at the next question. This is an easy question, very easy question actually. I gave 2 minutes for it, but I hope to see many people get it correct within the first 1 minute. Okay, many people got it correct, man. This is a very easy question. But again, very interesting and very happy to see that Vishalata got it correct again first, followed by Priyal Gupta. Again, she got it second. Jagat Raidu Jagat third. Naman Agarwal, Yash Vadva, Devesh Gupta, Sarma Akhilesh, Pratik Purohit, Nitin Chanakyagunam. All of these guys got it correct. Sanyam, Vikas Sudri, Sonima Dwivedi. All of you have done well. Very good. Okay. Surya Tej, I'll look into your doubt. Let me first explain this, and after that I'll explain your doubt. In this triangle ABC, there are points D and E which are on the sides of, okay. For some reason I hate this red color. So yeah, D and E are on the sides of AB and AC respectively, such that DE is parallel to BC and AD is to DB is 2:5. AE is 4 centimeters, then find AC. So let us again first draw the triangle. This is the triangle ABC. This is A, this is B, and this is C. Now D and E are points on AB and AC. So this is D and this is E, such that DE is parallel to BC. So again we have a line which is parallel to BC. Okay. AD is to DB is 2:5. So let us assume that this is 2A and this is 5A. AE is 4 centimeters. This is 4 centimeters. Find the length of AC. So because ADE is similar to ABC, and how do we know that these two are similar triangles? Because angle A is common, angle D and angle B are corresponding angles, they will be the same because D is parallel to BC. Angle E and angle C are also corresponding angles, they will also be the same. So all the three angles of ADE and ABC are the same. So both of them are similar triangles. So the ratio of AD divided by AB will be equal to AE divided by AC. Now AD is equal to 2A. AB will be 2A plus 5A, which is 7A. So 2 by 7 is equal to AE, which is 4 divided by AC. Or the length of AC is equal to 7 into 4 divided by 2. This is equal to 14 centimeters. So the answer for this question is option B, which is 14 centimeters. Let us look at the next question, and after that I'll look at the chat. This is an interesting question, guys, maybe slightly lengthy. I think I gave 2.5 questions, 2.5 minutes for this. Try to answer it. But an important question I felt, so I put it. Aderla Suryatej is saying, I want to start CAT for coming years. Where to start and directly jump into mock test? No, I think jumping directly into mock test is not a good idea if you haven't started your CAT preparation. I would say download the PDF of the CAT previous year's papers. Try to look at the questions so that you first get a sense of the type of questions that are asked. Even if you are not able to answer them, you should first get a sense that okay, these are the kind of questions that are asked. This is, and also know about the examination. What is the time limit? What are the portion? How many questions are there in each of the sections? So try to understand the basics first before you jump into mocks. Basically, you have to take the mocks very seriously. You should not just take the mocks for the sake of it. Okay, we got 181 likes, guys. I need just another 119 likes before the stream ends. Please do like the stream, guys. We are putting in a lot of effort. When you like it, the stream will be promoted to more people and more people will join us, which will motivate us to do this kind of streams very regularly. So please do us a favor and please do like the stream. Yeah, I don't think anybody got it correct, which is interesting, man. Think. I told you, this is not a very trivial question. This is a slightly complex question. Not very difficult, but slightly complex. Okay, Noob Coder got it correct. Priyal Gupta also got it correct. Swastik Bansal, Devesh Gupta, Mahesh Koje, all of you guys have gotten it correct. The correct answer is what you guys have mentioned. Umang Srivastav, all of these guys have mentioned it. Well done. Let the time be done and then I will explain the question. Yeah, Aditya Kumar, Sonima Dwivedi, Vikas Chaudhary, Akriti Agarwal, all of you guys have gotten it correct. Well done. Okay, time is up. Let us try to answer this question. ABC is an equilateral triangle. D and D are midpoints of AB and AC. If the area of ABC is 8 square units, what is the area of the triangle BDE? So we know that ADE is similar to ABC because D and D are midpoints. So both of them will be parallel. Okay, I don't know how to write it. Okay, let me get my. So this is parallel to this. All of them will be 60 degrees, all the angles. So both of them are similar triangles. Now once you know it, the lengths of the sides are 1:2. That is AD divided by AB is 1/2. So you can immediately tell the area of ADE. The area of ADE divided by the area of ABC, this will be 1/2 whole square. Because they are similar triangles, the ratio of their areas is the square of the ratio of their sides. The ratio of their sides is 1:2, so the ratio of their areas will be 1:4. Now area of ABC is given, this is 8 square units. So the area of ADE will be 2 units. Now what is important over here is to then infer that the area of the trapezium BDEC will be 6 square units. Now if you assume that the length of BC is say 2x, the length of DE will be x. And for this trapezium, if you assume that the height of the trapezium, that is the distance between these two sides, is say h, what is the area of triangle BDE? Area of triangle BDE is equal to half into base into height. What is the base? The base is x and the height is h. Area of BDE is half xh. What is the area of BEC? For BEC, the height is the same. For both of the triangles, the height is the same, the height is h. But for BDE, the base is x. For BEC, the base is 2x. So this is half into 2x into h, which is equal to xh. Essentially what we are saying is that the area of BEC is 2 times the area of BDE, because the base of BEC is 2x and the base of BDE is x, which is half of it. Now the area of the trapezium is 6 units. If the area of the triangle BEC is twice the area of triangle BDE, it would imply that this has to be 2 units and this has to be 4 units, because the overall area of both of them together is 6 units. So what we are required to calculate over here is the area of triangle BDE, which will be equal to 2 square units. Now I will be honest, when I first solved this question and when I was solving it quickly, I answered it as 3 square units and I went to the next question. Later I realized that it was a mistake. Why did I answer it as 3 square units? Because I felt that okay, the trapezium, the area of this trapezium we got, the area of this trapezium we found out is 6 square units. Once I realized that it was 6 square units, this is one diagonal. I am just used to a diagonal dividing the square in equal parts, or a rectangle into 2 triangles of equal area. So I just assumed that this will be 3 and this will be 3, but that is a mistake. The areas of these triangles are not the same. The areas of these triangles are in the ratio of their bases. This is x and this is 2x. So the area of the bottom triangle will be twice the area of the upper triangle. So this will be 2 and this will be 4. This is what we are asked to calculate. This will be the answer. Let me look at the next question. Guys, let me request you again, please do like the stream. I really want to get to 300 likes before the stream ends. We can also solve it if we take midpoint of BC, say F, join DF, which will be 1/4 the area of BC. I think you can do it. Yeah, I think that also is a smart way of doing it, Devesh. Well done. That is a good way of doing it. So D is median of AB, ADA and BD will be equal. DABC, DE is median. I think maybe that is true, I am not sure. I can't picture it right now. Okay, this is an interesting question. I think I know the answer. Yeah, I remember the answer. But Vishal Datta, your answer is not correct. You have been answering very quickly many times. This is not a very trivial question. This is not a very difficult question. This is not a simple, very simple question. So take your time and try to answer it. Devesh Berry, no, please try again. I'm very interested to see who will get it first. Not correct Chirag or Yesh or Jagat Raidu or Sonima Dwivedi or Narayan or Priyal Gupta. Take your time, guys. Try to get it correct. You still have, I didn't switch on the timer quickly, so I'm still giving you 2 more minutes. Try to answer it. Okay, Naman, I think you got it correct first. Well done, Naman. That is the correct answer. And Soumya Srivatsa answered it just behind Naman. But yeah, now many people are getting it correct. Well done. But I will give a shout out to Naman and Soumya. Both of them I think have gotten it correct at the start. Swastik Bansal, yes, you are right. So 3 people have gotten it correct. Yes, you have time, so if anybody wants to give the explanation, you still have 1 minute about how you did it quickly. If you can do it, that will be great. Yes, you are correct, Devesh and Vikas Chaudhary. Yes, you are correct, Sonima. Okay, we need just another 1 or 4 likes, guys. I'm sure we can get it done. Please do share it in any groups that you might know to get more people to join it. We just need another 1 or 4 likes. Kushal Sagar Kumawat, do you select RCs in VRC or do you what you see first? No, I do actually select the RCs because I feel that based on the topic of the RC, I can concentrate better. So if the topic is something I'm interested in, I can concentrate easily. So that's the reason the first 2 RCs I feel are very crucial for me. I want to get very high accuracy in the first 2 RCs that I see. Because if I get stuck in an RC or if I feel that okay, in the middle of the RC, I feel that okay, I'm not able to concentrate or I feel that I'm messing it up, I think the exam I'll start poorly and I don't want that like lack of confidence at the start. That's the reason the first 2 RCs for me are very crucial. So I select the 4 RCs, I also select a order in which I want to attempt the 4 RCs. The first 2 RCs, typically I select RCs which I like, the topic I like or topic I'm interested in. Okay. Let us try to answer this question. In a triangular park ABC, DA is drawn parallel to one side of the park BC. Okay. So let us first draw. This is the park ABC. This is A. This is B. And this is C. Now DA is drawn parallel to one side of the park BC. So let us assume that this is DA. This is D and this is E. It is given that the length of DA is 1/5 the length of BC. Okay. So if DA is parallel to BC, one thing we should first immediately confirm is that triangle ADE is similar to triangle ABC. Because all the angles will be the same, these 2 are parallel. So angle D is equal to angle B. Angle E is equal to angle C and angle A is constant. So all the angles are the same. The second thing we are told is that DE divided by BC is given. This we are told is 1/5. So we can calculate, and I think we are also given the area of triangle ADA. It is given to be 16 centimeters. So area of triangle ADA divided by area of triangle ABC, this ratio will be square of the normal ratio, square of 1/5. So this will be 1/25. AD is given to be 16, so ABC, the area of ABC will be 16 into 25, which is equal to 400 square units, or this is okay 400 centimeters square. Once that is given, we are asked to calculate the difference between the areas of triangle BCD and CED. So basically we have to draw this line over here. This is BCD and then that is CAD. How can you calculate it? if you assume that this is, if DE is equal to say x, BC is equal to 5x. If you assume that the height of this trapezium DEC is equal to h, what is the area of triangle CED? Area of triangle CED is equal to half into base into height, which is half into x into h. Similarly, what is the area of triangle BCD? Is half into base into height, but the base of BCD is 5x. So this is half into 5x into h. So if you assume that this area is A, this area is 5a. The area of BCD is 5 times the area of triangle CAD. What is the sum of the two areas? The sum of the two areas is 6a. But this 6a has to be equal to 400 minus 16. Why is that the case? Because area of triangle ABC is 400. Area of triangle ADE is 16. So area of triangle of this trapezium BDEC will be equal to 400 minus 16, which is equal to 384 square centimeters. Now that is equal to, this is A and this is 5A. Because area of CED is, we assume to be A, area of BCD is 5 times that, because the base is 5 times as much as longer. So this is 6A. 6A is equal to 384, or the value of A is equal to 64 centimeter square. What are we required to calculate? We are required to calculate the difference in the areas. So what is 5A minus A? 5A minus A is 4A. So 4A is equal to 4 into 64, which is equal to 256 centimeter square. So the answer for this question will be 256. Let me look at the next question. Okay. 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 I think I think this should be okay. I am trying not to come into the video. Ankush Vishwakarma, sir, in how many days can I cover geometry? I have finished algebra and arithmetic. Geometry, I would say, like today we are doing triangles and circles. Let us see if we have the time to do circles, but triangles and circles is what we are focusing on completing today. So this is half of the geometry. The other half will be polygons and solids and mensurations. Ankush Vishwakarma, should I pick number system or geometry? I would say geometry I think is better. Geometry I think is more important. So focus on geometry. Suryatej sir, thank you sir. I have a doubt, like if I prepare only important topics as for weightage for each subject, should I skip less weightage questions like modern math, only one question like this? Modern math, I don't think you get only one question. Modern math includes functions, logarithms, all of them, and you get more than one question. Right now, focus on the important things. If you are starting your CAT preparation, I would say focus on arithmetic. That is by far the most important topic, and then take it forward from there. Dash CAT is taken by a few thousands, man. I think Xerox got it correct. I think it is 4:1. Devish Berry is saying, sir, 11, 11, 11, is it a good score? I would say you have to increase your attempt rate, man. If you are attempting only 11 questions, I would feel that you are attempting lesser. I would recommend you to attempt more. Okay, consider the triangle PQR as shown in the figure. S is a point on QR, okay, here, and T is a point on PS, okay, I don't know how to, oh. Let me ask somebody to come and fix it. I don't know what to do. Okay. Okay, I think it is back, so let me try to solve it here. Okay, so basically what we are told is S is a point on QT, on QR, T is a point on PS, okay, it is known that RS is equal to 2QS and area of PQR is 15 by 8 times PRT, okay. Then find the ratio of PT is to TS. So let me just draw this figure here so that I can explain it better. Let this be PQR. This is P, this is Q, and this is R. Now we are given S, RS is 2 times QS. So if you assume that the area of triangle PQR is say 15A, then the area of triangle PRT will be equal to 8, because this ratio of PQR to PRT is given, that is 15 by 8. So I assume PQR to be 15A, so PRT is 8A. Now if you join P to S, there is some element S here such that RS is 2 times QS. Now if RS is 2 times QS, you can get a ratio of the area of RPSR to PQS. This will be equal to 2:1, because the ratio of the areas of the triangles is equal to the ratio of their bases. That is because the height over here, which is the distance between P and QR, is the same. For both of the triangles, the height is the same, so the ratio of their areas is the ratio of their bases. So if PSR by PQS is 2:1, area of PSR will be 10T and area of PQS will be 5A, sorry. Because the overall area we assumed is 15A, that will be divided into, this will be 5A and this will be 10A. Now you are joining R to T over here. This is a point T. Now area of triangle PRT is 8A. So if this is 8A, this has to be 2A, because the overall area of PSR is 10A. Now again using the same theory, the ratio of the areas of PTR or PRT to SRT will be equal to the length of the ratio of their lengths, which is PT by TS. Now PRT is 8A, SRT is 2A, therefore PT divided by TS will be equal to 8 by 2, which is equal to 4 by 1, which is 4:1. Let us look at the next slide. Let me look at the chat if there is any doubts, and after that we'll go to the next slide. Guys, we got 202 chat, 202 likes. We just need another 88 likes. Sorry, 98 legs. While teaching geometry, my additions are getting messed up. Okay. This is the next question. Tushar Gautam is saying, sir, I completed all the videos of math and from geometry playlist and it helped a lot, but most of the questions are very easy. Can you please make a playlist of harder level geometry questions? Sure, man. I'll try to make a playlist of slightly tougher questions in geometry. Akriti Agrawal, sir, why did you take square of PT and PS? PT and PS. PT and no, I didn't take the square of PT and TS. So I'll just explain quickly what I did in the earlier one. This was basically the triangle. I think this is P, this is Q, this is R, and we have an S over here. If I'm assuming that PQR is 15A because I wanted to avoid fractions, this is PQR. I'm sorry, man, I'm coming in the middle of this. PRT will be 8A. So I'm saying this is 5A and this is 10A. Now we drew another line over here. This is T. This is given to us as 8A. This is given. So this will be 2A. So the ratio of this PT to PS will be 8:2, which is 4:1. Okay. Some people did not understand the earlier question. I'll explain it after the time for this question is over. I'll go back and I'll quickly explain it. Yeah, I think Raidu got it correct first. Yeah, the correct answer is what you mentioned. No, Aryan, it should not be root of 8/2. I'll tell you why also. I'll explain that. I think that is what is complicating people. I'll explain that. Just let the time for this be over, then I'll explain it. When we take area of two triangles as ratio, we take square of sides. Okay, I understood your doubt, Akriti. I'll explain it. Okay, let us assume, I'll come to this question after I explain the earlier question again. Just give me 1 minute so that people will understand it better. So basically what we have mentioned is, don't get confused between a couple of things. Suppose this is one triangle and this is another triangle. Suppose both of the triangles are similar to each other and you are told that okay, this is 5 and this is 1. Then the ratio of their areas will be 25:1. There is no confusion over here. Why is that the case? The ratio is 25:1 because all of these sides, this will be 5 times this. This will be 5 times this. So if you assume that this is A, this is B and this is C, this will be 5A, this will be 5B and this will be 5C. All of the sides will be 5 times it. In addition to it, even the height, if you draw a perpendicular from here to here and you draw a perpendicular from here to here, if this perpendicular is H, this will be 5 times H. Therefore, the area will be 25 times that. There is no confusion there. In fact, if you are using the area of the triangle, it is half into base into height. The base over here is 5A and the height over here is 5H. So this is 25AH by 2. And in this particular case, it will be AH by 2. So again, like we assumed or like we guessed, the area is 25 times. There is no confusion here. But the question that we talked about is different. It is slightly different. The question we talked about will be something like this. Here is a triangle. Now this triangle is divided into two parts. This is say, I think this is 1 and this is 2. So let us assume that this is A and this is 2A. In this triangle, this is P, this is Q and this is R and this is S. Here PQS is not similar to PQR or PSR. What is the relationship between PQS and PSR? The relationship is that both of them have the same height. This height is the same for both of them. This is h. The height is the distance of P to the line QR. That height is the same for both of the triangles. So again, if you are using the area formula, which is half into base into height, it will be half into A into h for PQS and half into 2A into h. This is for PSR. These two are not similar triangles. So the relationship between them is that the height is the same. And because the height is the same, the area is in the ratio of their bases. In the earlier case, they are similar triangles, so the height is not the same. The reason we are getting square is because we are getting a 5 over here, which is the ratio of their base, and we are getting a 5 here, which is the ratio of their height. In the below case, the heights will be the same, so we are only going to get 1, 5. That is the difference. I hope it was clear. Let us solve this question. In a triangle PQR, PA is the median of the triangle. So let us assume that this is PQR. This is P, this is Q, and this is R. PA is the median. So you draw the median, this is PA. The angular bisectors of PAQ and PAR. So this is an angular bisector, and this is another angular bisector. Intersect PQ at B, so this is B, and it intersects PR at C. It intersects PR at C here. Okay. Now PB is to BQ is 2:1. So if you assume that this is 2A, this is A, then the ratio of PC is to CR is. Now let us assume that because PA is the median, let us assume that the length of QR is equal to 2y. So QA will be equal to y and AR is equal to y. Now using the angle bisector theory, this is an angular bisector theory, the length of BQ divided by the length of BP is equal to the length of AQ divided by the length of AP. Because if you have a triangle like this, and if you are drawing an angular bisector like this, if this is the angle bisector, the ratio of these two sides is equal to the ratio of their adjacent sides. So in this particular case, BQ by BP is known to us, this is 1/2, is equal to AQ, which is y, divided by AP, or the length of AP is equal to 2y. So this is equal to 2y. Once we know that that is equal to 2y, we will apply the same theorem of angle bisector on the triangle PAR. So in PAR, this is the angle bisector. So PC divided by CR, which is what we are required to calculate, is equal to PA divided by AR. Now PA we know, or AP, this is equal to 2y, and AR is equal to y. So this required ratio of PC divided by CR is equal to 2:1. Let me know if you guys have any questions. Aryan place, no squaring because height is the same and only base is changing. That's absolutely right, Aryan. Okay guys, one thing I wanted to tell you is that we have a crash course which is starting on Monday. This is the support number. If you are looking to enroll to any of the crash course, you can contact us at this number. It is a very good course. It will provide you daily schedule. It will also provide you our dash cats, and we also have live classes from Monday to Friday at 8 p.m. in the evening. So if any one of you is interested, you can contact us on our support number. This is the details of the crash course which is starting on Monday. So that is it for today, guys. We will conduct the next one, which will be on circles. We will conduct it most probably next week. If you have any doubts with respect to any of the things that we have actually mentioned, please do let us know in the comments. I look at all the comments and I'll try to get back to you to the best of my ability.